In this session, I will talk about two things: the architecture for Python and how did Python become popular. The architecture for Python includes three main parts: the source code, bytecode, and Python virtual machine, also known as PVM. Source code is the code where we write in an IDE. IDE stands for Integrated Development Environment, and it helps us to develop our program. The source code is a list of commands or collection of code that has syntax for Python. It has a py extension. When we are finished writing our source code, then the next step is to execute the source code. Each line is checked to make sure there are no errors. If there are no errors, then the source code is converted into bytecode. The bytecode is platform independent, efficient, and represents our source code as instructions in a particular format. However, there is a difference between source code and bytecode. The source code is a high-level language, and bytecode is a low-level language. High-level languages are used to create software and test scripts like Java and C#. A low-level language contains basic instructions. For Python, the bytecode contains instructions executed by the PVM. As soon as the source code is converted to bytecode, then the bytecode is sent directly to the Python virtual machine PVM. The PVM is an emulator and operates as the runtime engine of Python. Just like the CPU executes machine code, that's how the PVM executes bytecode. Now, how did Python become popular? One of the reasons Python is popular because of the rise of AI, machine learning, and data science. Most of us know AI is artificial intelligence. It is intelligence carried out by machines. Machine learning is the study of computer algorithms. Data science is the study of getting insights and information from data. Do you see the connection? With all of this intelligence, algorithms, and information, it has to be processed. Python is a good language because it has built-in modules to process that request. Another reason Python is popular because the syntax is concise and easy to pick up. Some schools are starting to use Python as the first language to introduce programming. For Selenium automation and Python, more and more testers are interested because they can write their test scripts with easy to pick up languages and syntax. If you're interested in Python, subscribe to my YouTube channel, click the bell icon, also follow me on Twitter, connect with me on LinkedIn and Facebook, and I will see you in the next session where I introduce Python by installing Python and installing PyCharm, which is the IDE for Python. And thank you, and I'll see you in the next session. In this session, we are going to install Python and PyCharm. Python is the programming language. PyCharm is one of the IDEs that let us write our Python code. Start by going to python.org.downloads/downloads. We see Python is available for multiple operating systems: Windows, Linux, Mac, and others. I am using Windows, so I would click this Download Python 3.9.2 button. 3.92 is the Python version. Let's head over to my Downloads folder and see Python. Now, with this here, this dialog shows Install Now and Customized Installation with two checkboxes. The two checkboxes is Install Launcher for all users recommended. It's already selected. We're going to make sure to select Add Python 3.9 to path. Then click Customize Installation. Now, at this point, we are at the Optional Features dialog, and this shows 5 checkboxes already selected. Now, at this point, all we do is click Next. On this Advanced Options window, we click the first checkbox, Installed for all users. Notice this Customized Installation, it changed when I had selected Install for all users. Now we click Install and click Yes on that pop-up. Now it's setting up and it's in progress, the installation. The setup was successful. At this point, we can verify Python is installed by going to the command prompt. Go to the Start menu, then type CMD for command prompt. Let me make this a little bigger because I know it's kind of small. And we're going to type Python space 2 hyphens version enter. And we see Python 3.9.2. We are finished installing Python. Now let's install PyCharm. We're going to write a bunch of code, so we need the PyCharm IDE or any text editor IDE. IDE stands for Integrated Development Environment, and it is a special text editor environment with the purpose to help us write our source code and run our source code. It also lets us know if we made a mistake with our code and point us to the right direction to fix our code. Go to jetbrains.com/jetbrains.com/PyCharm, and it says PyCharm, the Python IDE. Click download. We see 3 operating systems: Windows, Mac, and Linux. Also, there's a professional version and a community version. The professional version is a paid version, but it has a free trial. We're going to select the community version because it's free and open source. It has everything we need. Click download. And there's a few seconds left before it finishes downloading. Now I'm getting ready to open. Bingo. Now with the Welcome to PyCharm Community Edition setup. So now we open the file. On this setup, we click Next. And now we're at the point where we choose our installation location. And I'm going to leave it as default and click Next. Now, with the installation options dialog, and I'm going to make sure to check the 64-bit launcher and add launcher's dir to the path. Then click Next. Now we are going to see to click Install so it shows up in our Start menu. There are 2 options: reboot now or reboot later. I'm going to go ahead and click reboot later and then click finish. Now let's make sure it's available in our Start menu. Click the Start menu and we see PyCharm Community Edition is there. Uh-oh, let me do this again. There it is. And we see PyCharm is loading up. You may get a pop-up that says import Python charm settings. Import PyCharm settings. Click do not import settings if you have no existing settings. Now we have installed Python and PyCharm. We're ready to start writing code. In the next session, before writing the code, I will show you how to configure PyCharm. Thanks for watching, and I will see you in the next session. In this session, we are going to configure PyCharm and write a hello world program. By default, we see I have a dark color scheme. I will show you how to change the color if you want to change the color. Click New Project. The base interpreter shows Python 39.exe. That's important. Recall from installing Python, the location changed when we customize the location. If you have a different base interpreter, you can select it by clicking the drop down or by selecting previously configured interpreter. Click the three dots, ellipses, then select system interpreter and select the correct interpreter. I'm going to click cancel since I already have the right interpreter. Make sure this checkbox is unchecked. Welcome script. Create a main.py welcome script. It's unchecked because we are going to write our own script. Select the radio button, new environment using virtual environment. Then click create. At this point, we'll send the virtual environment create. And when it finishes loading, then we're going to go ahead and create our first program. We create the first program by right-clicking Python project. New Python file. The name will be first_program. Then hit enter. Now we can start by writing print. Double quotes. Hello world. Let's also add Python programming tutorials. We can run this program different ways. We can right click and select run program. We can also click run from the menu and select run. Also, we see a shortcut that says Alt Shift F10. There's also a shortcut when we right click and we see Control Shift F10. Right now, the play button is disabled, but when it's green, we can also run by selecting the button or the shortcut Shift F10. For now, let's go ahead and hit run first program. And in the console, we see it shows hello world Python programming tutorials. Configure PyCharm some more by going to File, Settings. This appearance is where we change the theme for the entire project. However, I only want to change the theme for the editor and the console, so I don't change it here, but we see Darkular is the default in the dropdown. We also see IntelliJ Light, Windows 10 Light, Darkular, and High Contrast. I prefer High Contrast. Go to Editor, General, and this checkbox, change font size with Control plus mouse, wheel. This option lets us adjust the font with the mouse. To permanently adjust the font, we go to Font. Then change 13 to 16 or any size you choose. And one more thing I want to show you. I want to show you the color scheme where I normally change the theme from Darkular to High Contrast. I said one more thing, but know what? This is one more thing I want to show you. I like to change the indents. So to change the indent, I go to the drop down for code style, then Python, and I like to change it from 4 to 2. So now tab, it don't go as far across. And that's it. So now I'm going to click apply, and we already see it kind of changing right here in the preview. And I'm going to click OK. And in the console and editor, it has increased the font and the theme has changed to high contrast. Here's the font. It changed to 16 in the editor and console, and we see the high contrast theme. If you want more information about configuring PyCharm, you can go to jetbrains.com/help/PyCharm/configuring-project-IDE-settings.html. That's it for configuring PyCharm and writing our first program. Thanks for watching, and I will see you in the next session where I'll show you how to create and name variables. A variable is like a container in the computer's memory that allows us to store a value. We store that value with an assignment statement. The complete assignment statement consists of a name, equal sign, and a value we plan to store. Here are some of the rules for naming a variable. Variables can include letters. Variables can include an underscore. Variables can include numbers, but variables cannot start with a number. Also, variables cannot contain spaces or special characters. Let's go to PyCharm and create a module. Right-click Python project, new Python file. A Python file is called a module, and the purpose is to organize our Python code. The convention for modules and the variables are the same. It contains all lowercase letters. The name will be name underscore create underscore variables. Then enter. A good variable name is descriptive, so it should describe the value. Our first variable is name. The variables are case sensitive, so age with a capital E is different from age with a lowercase e. There are two ways to write a variable that has more than one word. Some people use camel case by writing a lowercase letter like is, followed by a capital letter for every subsequent word like male. This variable has two words called is male. The second way is separating all words with an underscore like full underscore name. I use both ways, but most of the times I use an underscore to separate the words. Personally, I believe an underscore improves readability. Another word to write for a variable is a constant, and constants have all capital letters like P-I. That's an indicator that the constant has a value that will not change. We also separate constants with an underscore if it has two words. I like math. Math was my favorite subject. Pi is a constant that has a value equal to 3.14. The equal sign is an assignment operator, and 3.14 is the value. A variable is initialized when a value is stored in it the first time. Let's create some variables like full name equal to Rex Allen Jones the second. Is male equal to true with a capital T. Age equal to 34 and name equal to Rex. Did you notice how the quotes for name and full name are different? Name is located inside single quotes and full name is located inside double quotes. Either way is okay. Let's print the values. Print name. Print age. Print is male. Print full name. And print PI. Let's hover print. And the description says prints the values to a string. In other words, the value will show up in the console. Let's run. Yes. The console shows each value for name, age, is male, full name, and PI. Name shows Rex. Age is 34. Is male, true. Full name, Rex Allen Jones II. And PI is 3.14. If you want to, you can combine the variables. For example, age can be combined to 34 by separating it with a comma after the variable name, age. And the value get placed after the value with the comma, and we put 34. Now, let's change the previous value to 43. If I print, do you have any idea what value will show up for age? Will it be 34 or 43? Let's run. The value that showed up for age is 43. 43 is the value because it was initialized to 34, but assigned a new value of 43. This is what we call overwriting the variable. The old value is gone and forgotten. That's it for naming and creating variables. Thanks for watching, and I will see you in the next session. In this session, we are going to work with some variables. When it comes to programming, we manage a lot of information. As a result, variables help us deal with that information because a variable is a memory location. I will use a short story with a few print statements to show you how we can handle and work with variables. Let's add maybe 3 print statements. Print, print, and print. Now, no, let me add some more. Print. It's better to have more than not enough print. And maybe that's enough. Okay, now I'm going to start with double quotes and also show you how it would print with double or single quotes. Hi, my name, and I hope my typing go good this time. Hope my name is Rex and I am a software engineer. Uh-oh, it's not going good. Skill set includes, come on typing, includes programming, automation, and testing. 5 years as a functional tester and 10 years with automation. In the future, I hope to be a software engineer. I like it and don't plan to change. Let's run. We see the same story in the console. Hi, my name is Rex and I'm a software engineer. Skill set includes programming, automation, and testing, 5 years as a functional tester, and 10 years with automation. In the future, I hope to be a software engineer. That's cool, but what if 100 more people wanted to introduce themselves using this program? For example, the name changed from Rex to John. To update this program, I can manually change Rex to John. However, that would take a lot of work because the name and title will probably change. Let me show you how working with variables can make this useful and easy. We can store the information inside a variable. One way is to hard code the value, and another way is to prompt for the value. Let's start with hard coding a value. Above the story, I would write name equals James. I'm storing James inside the name container, or we can say memory location. Next is title equal to software tester. I'll change it. Let's add some more values for years of experience. Functional years equals 10 and automation years equals, let's write 20. Now we replace the values in the story with a variable. Replace John with the variable name, but I have to end the print statement with double quotes before the name variable, then add a plus before name and after name, and then start back over with the print statement. The plus signs appends the name variable. Appending a variable is like attaching the variable. It's the same. Here is the process Python will get the value from the variable, then print the value. Replace software engineer with title. And I'm going to append with the plus sign. And I'm going to go ahead and just make this here double quotes also. Now, I'm going to also change 5 to functional years. Add the plus sign and the double quotes. And 10, change that to automation years. Add the plus symbol and the double quotes. And I cannot forget to put the plus before automation years. Also, title for the last part. And that's it. So now let's run. And we see the same story, but the values change. James, 10 years, 20 years. Software tester also changed. And let me go back and add a space right here before and. But we see how the values did not, there we go. Now, we see each value change in the console. The nice part is a value can change all the time. We don't have to type in the name every single time, but only refer to the variable in the story. That's it. Now, let me show you how to prompt for a value by writing a few print statements. Print, what is your name? Now, I have to also add an input, but replace the hard-coded value James with input. And we see here it shows prompt, because this will prompt us for a value. Add another print statement, and that will be, what is your title? Change software tester to input. Functional years. I'm going to write a print statement and say, how many years of functional testing? I'll put that. And I'm going to copy this and put the same for automation, but just change functional to automation. If I hover input, we see the description says, read a string from the standard input. There will be a prompt and I will enter a value. The value will get stored inside the variable. In the previous session, I showed how to overwrite a value. Let's modify and overwrite title by putting in adding a blank line and putting in title equals CTO. Now let me also put in the input for the functional and automation years of experience. Now let's run. What's your name? Joe Doe. What's your title? Scrum Master. Functional years, I'm going to put 12. 11.5 for automation. And here's the story. It reads, hi, my name is Joe Doe, and I am a Scrum Master. Skill set includes programming, automation, and testing. 12 years as a functional tester, and 11.5 years as automation, or with automation. In the future, I hope to be a CTO, Chief Technology Officer. That's it for working with variables. I want to show you how it's useful. And thanks for watching, and I will see you in the next session. Thanks. In this session, we're going to discuss comments and data types. A comment allows us to write notes in our program. A data type has a category for every value. For Python, we do not have to declare the data type. Let's start with comments. So far in our program, we have written Python code. We use comments to explain what our code should do and how we make our code work. A hashtag is an indicator that our program has a comment. There are 3 ways to write a comment. Single line, multi-line, and doc string. The interpreter will ignore everything following the hashtag. This is a single line comment. We use single line comments to explain a code statement. A multi-line comment has multiple hashtags. Most of the times, we use multi-line comments to help our fellow programmers read the code and explain our code in more detail. The doc strings comments is different. We write the double quotes 6 times and a note after the third double quote. A doc string comment is used to describe a module, function, or object. It's common practice to start a Python program file with a few lines of comments to describe the purpose of the file. When it comes to the data types, Python has 3 common data types. They are integer, float, and string. Integer is also known as int. Float is also known as a floating point number. And the string can be written as str. An integer is a value with a whole number. Floats are numbers with a decimal point. Strings are a series of characters surrounded by double quotes. They are surrounded by quotes so Python understands where the string starts and where the string stops. Strings are written with double quotes inside double quotes or single quotes. Since Python is a dynamically typed language, we can bypass writing the data type. However, if we want to be explicit, we can write the variable and data type. For example, the normal way of writing a variable is age equals 34. That's the convention. This is an int data type, but we can add a colon after the age, then write int. Recall int data types are whole numbers, so it can be written as temp equals -3. Negative values are also whole numbers. How about a floating point number? Price colon float equals 56.78. The conventional syntax is number equals -12.34. A string is written as the same way, but only use 3 letters. For example, full underscore name colon str equals Rex Jones II. This is double quotes, and single quotes are written like Nick underscore name equals single quotes James Jones. It's true that a single quote, it's true that a string is a series of characters. That means that it can be letters, numbers, and special characters. So we can also write a string like cost underscore of underscore product equal to, let's say, $74.99. This is also valid for a string, even though it includes numbers. Also, when it comes to a string, we can write blank string that's equal to quotes only. These are the 3 common data types: integers, floats, and the strings. However, we have more data types like Boolean types, sequence types, mapping type, set types, and binary types. Boolean is known as bool and only contains true and false values. For example, is male colon BOOL true. The true and false values must begin with the capital letter. Let me show you how to print the data types. You know what? Let me do one more. Like, is displayed equals false. Just add one for true and false. And let me print some of these values to show you how it looks. For example, we have print temp, print, and I'm going to print the data type by writing type and the value inside the quotes. And I'm going to skip a line. Now let's try print, how about number? And print the data type for number by writing type, and inside the parentheses we write number. And I'm going to skip a line. Next, I'm going to write print, how about is displayed? Let's do that one. And I'm going to write print type is displayed. Not male, but write displayed. Skip a line, and how about one more for the string, and that will be print nickname, and the type for nickname should be string. You know what? Let's run. We see the console shows each value with their data type. -3 is an int. 12.34 is a float. False is a Boolean, and James Jones is a string. That's it for comments and data types. Thanks for watching, and I will see you in the next session. In this session, we are going to look at how to format some strings. Recall in the previous session, I said strings are a sequence of characters surrounded by quotes. The quotes can be single, double, or triple. A triple quote is when I showed a docstring comment. When it comes to formatting a string, it is good for generating some text with our variables. Dynamically, it's easy for us to see the output when writing our code. For example, let's create two variables. First underscore name equals Rex. Last underscore name equals Jones. To format a string for a variable like name, we start with an F, then quotes. The quotes can be single or double. Inside the quotes, we write two curly braces, opening and closing. Then inside the curly braces, we write a variable. This variable will be first name. Two more curly braces. And inside these curly braces will be the next variable, which is last name. The purpose of each curly brace is to provide a placeholder for our string. When running our program, the placeholder will be replaced with the value from our variable. Next, we write print name. Then we run. The console shows Rex Jones. Notice how automatically a space is added between the first and the last name. That's because it is formatted. I got something else. Erase everything except for first name. In the last session, I said a docstring comment has 6 quotes. It could be single or double. These are considered triple quotes because it's 3 quotes on each side. Let's make the comment be hello, opening and closing braces. Hello, how are you doing today? Question mark. I hope all is well, period. Have a great day. Now, we know an interpreter ignores a comment, but not if the comment is assigned to a variable like greeting. Now, it's no longer a comment, but it's a string value. To make this a formatted string, we prefix the quotes with an F. Did you notice how the curly braces change colors? It changed from green to orange. We print by writing print greeting. Greeting dot format. And inside format, we write first name, which is the variable. The format method returns the formatted string. In this case, first name is a formatted string. So I add first name inside the curly braces. Let's run. The console shows, hello, Rex Jones. How are you doing today? I hope all is well. Have a great day. We can also format a string without starting the string with an F. I will remove the F before the single quotes and remove the first name from inside the curly braces. Now it looks like there is no reference to a formatted string. However, first name will still get passed into the curly braces. We already have a value for first name, but this time let's call a prompt with the question. Either way would work. The prompt will be input What's your name? Question mark. Now, let's run. What's your name? James. Hello, James. How are you doing today? I hope all is well. Have a great day. Now, we saw that James was passed into the curly braces. We see the console show the same value except for the name change. That's it for formatting strings in Python. Thanks for watching, and I will see you in the next session. In this tutorial session, let's talk about string indexing and escape characters. A way to think of indexing is each character in a string is associated with the number starting at 0. An escape character allows us to use characters that will not cause a syntax error. Starting with the string index, let's write the truth as a variable with the value of "you are awesome." All indexes start at 0. Therefore, the first letter, which is Y, is indexed 0. I'm going to write a comment that will help us visualize the index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The complete string stops at index 10, 11, 12, 13, 14, including the spaces. We use the variable and the square brackets to get characters from the string by writing print the truth, square brackets. If we specify an index, we will get the character at that position. For example, to return the first character, which is Y, we write 0 inside the square brackets, then run. The console returns Y. To return the letter A, we change 0 to 4 because the fourth index. Bingo, the console returns the letter A. Python also lets us use a negative index. A negative index starts from the end, which is E, and it's the first index from the end. Therefore, we write -1. And let's see what happens when I run. The console return E. To return the capital letter A, we can either write 8 as a positive number, but starting from the back, we'll write 1, 2, 3, 4, 5, 6, 7. -7 would also give us the letter A. Bingo. The console shows letter A. Indexing a string allows us to also define a range. The range is from one index to another index. Here is the catch. It includes the starting index, but does not include the ending index. The substring would get everything from the starting index, then leave off the last index number. For example, the start index is 0, and a colon will help identify a range. 0 is for the letter Y, and the ending index will be number 9. We see W is index 9, but W will not be included. The letter A will be our last substring letter. Let's run. You are A. All right, we covered positive and negative indexes. So let me ask you a question. What will the substring be if I make the end index -1? Let's run. You are awesome without an E because it's not supposed to include the last letter. The range starts at 0 and stops at M. Now, I want to show you one more thing when it comes to these negative numbers. If a negative number is not included, by default, it will include the 0, last letter. You are awesome. Now, escape characters help us do one thing. It helps us to not have a syntax error. So that's why I'm going to copy the variable and the value, and I'm going to show you how syntax errors are prevented using an escape character. What if I wanted to add an apostrophe to this string by writing "you're awesome"? Do you see the syntax error? A syntax error is when the Python interpreter does not recognize our code. It's not valid. That's why it has a red line. The quote lets the interpreter know when our string starts and stop. In this case, the string starts at Y and stop at the letter U. Everything after the second quote is not recognized, so it causes a syntax error. To fix this issue, we replace single quote with double quote. Now, someone could say, you know what? I would just use a double quote all the time. But suppose I want to remove the apostrophe and add double quotes around the word awesome. We have another syntax error. The string "you are" included, but awesome is not included. We have a syntax error that will be fixed by using single quotes at the beginning and end. Therefore, we see in this example, the single quotes fix the error. So we see in certain cases, single quotes and the double quotes return a syntax error. That's why we have escape characters. And this is the part I wanted to show you. So let me start over with this value and write double quotes, "you are awesome," and double quotes around awesome. And we see the syntax error. Awesome is not recognized as part of the string. An escape character consists of a backslash followed by a character we want to add to our string. For example, we want to add double quotes around awesome. Therefore, we add one backslash in front of each double quote, and the error goes away. To prove the error goes away, let's print the truth and run. "You are awesome" is what the console showed. It also works for the apostrophe. Change the string back to single quotes, "you're awesome." To make this error goes away, we add a backslash in front of "you awesome." And let's run again. "You are awesome." We can use escape characters, this backslash, for a lot of commands. We can use it for a tab and a new line. To tab, we write "you are awesome" backslash T followed by "so smile." You are awesome, so smile. Both phrases will be separated on the same line. Let's run. You are awesome, so smile. And this shows the tab. To skip a line, all I need to do is change T to N. And this time they'll be separated, but on different lines. You are awesome, so smile. Know what? That's it for indexing and escape characters. Thanks for watching, and I will see you in the next session. In this tutorial session, we are going to look at string methods. When it comes to strings, they are immutable. That means the string value, which are a series of characters between the quotes, cannot be changed. However, we can create a copy of the string, then modify the string, or get something back from the string. For Python, there is a difference between methods and functions. The main difference involves an object. A method depends on an object, but a function does not depend on an object. Therefore, a method is dependent while a function is independent of an object. A method is attached to an object after writing a name and a dot operator. That attachment provides access to the data. There are a few differences, but one more difference is how we call the method and how we call the function. A method cannot be only called by its name. However, a function can be called only by its name. Our focus will be Python methods, but let me show you an example of a function. The name is tutorial with the value of Python for programming automation. We write the letter L to return the number of characters for len. Do you see the small f before len? That f lets us know this is a function. Recall, I said a function can only be called by its name. We're calling len with no other functions. Let's print the number of characters by passing in tutorial inside the len function, and then write print before the len function and run. The console shows 34. I'm going to write an L one more time. Do you see a small m before any of these words? We do not see an m because a method needs an object to be called. Now, watch what happens when I write tutorial.l. At this point, the IntelliSense is filled with m's. Let's select lower. The purpose of lower is to convert all of the characters to lowercase. I'm going to print, and you will see how all of these are lowercase. Bingo, Python for programming automation. We can also convert all the characters to uppercase by changing lower to upper. Let's run. Now we see Python for programming automation and all capital letters. In addition to converting the strings to upper or lowercase, we can also check to verify if the string is upper or lower by writing tutorial dot is upper. We can also write is lower. This will check to see if all of these characters are uppercase. This would return a true or false value. It would return true if the string is completely uppercase, or false if the string is not completely uppercase. Let's print and run. False, as expected. Now, something else that's unique about Python, it can combine all the string methods into one statement. So what I can do is check to see if it's upper after I convert the characters to upper. For example, tutorial upper. This will convert the string to upper. Now I'm going to check to see if it's upper. Print and run. Bingo. It showed true because they were all uppercase before it was verified if they were uppercase. Now, there are scenarios in Python where you want to find some characters and replace some characters. To find a character, we write tutorial.find. Let's find the letter A. There are two characters in this string with the lowercase a, but the interpreter would find the first character. Let's print and see what the console shows us. 16. It shows 16 because A in programming is the 16th character. Let's count. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now, the find method is case sensitive. That means this A is different from a capital letter A. Let's see what happens when we try to find this letter A. Print tutorial.find. The previous statement had a double quotes, but this time I'm going to add a single quotes and run. And it showed 23. So if this was 16, this is 17, 18, 19, 20, 21, 22, 23. Bingo. I have a question for you. What do you think would happen if we try to find a letter that's not in this string? For example, if I write the letter B and try to find it, what will the console show us? A -1. It shows a -1 because there is no letter B in this string. One more thing. I want to show you about the find method is we can search for a range of characters. Let's search for Python by writing print tutorial.find Python. And we see 0. It shows 0 because P is index 0. When it comes to the replace method, we write tutorial.replace. Let's replace Python 4. Add quotes, place the value we want to replace inside the first set of quotes. Then we have a comma and add more quotes. And the second set of quotes will have the value we want to replace it with. How about learn? Print and run. Learn programming automation. Bingo. Okay, we searched for a range of characters, replaced it. Let's search and replace a single character by writing tutorial.replace, and let's replace the letter F. It's lowercase. Let's replace it with an uppercase F. Bingo. The console shows capital F, Python for programming automation. That's a good stopping point. Thanks for watching, and I will see you in the next session. In this tutorial session, we are going to look at operators. There are 6 Python operators: AAC, LBB, assignment, arithmetic, comparison, logical, Boolean, and bitwise. The identity and membership operators are a subset of the Boolean operator. We are going to focus on the most used operators: assignment, arithmetic, comparison, logical, and Boolean. The purpose of an assignment operator is to assign a value to the variable name. Arithmetic operators perform a math operation on numeric values. A comparison operator is used to compare two values, and the logical operators combine statements that have a condition. Last but not least are the Boolean operators, which represent an expression that returns true or false. Let's start with the assignment operator. We have used the assignment operator since naming and creating a variable. It is the equal symbol that assigns a value. For example, course equals, let's say, Python step by step. This statement assigned Python step by step to course using the equal symbol. When it comes to an arithmetic operator, there are 7 operators. We have addition, subtraction, multiplication, division, modulus, exponent, and floor division. Recall in Python, there are 2 types of numbers. We have integers and floating point numbers. The integer is a whole number, and floating point numbers are numbers with a decimal. The arithmetic operators work on both types. Let's look at a few operators such as print, let's say 10 plus 3. We know the plus symbol represents addition, so the answer is 13. Yes, the console returns 13. Now I'm going to copy this statement and paste it 6 times. 3, 4, 5, 6. The second statement would be subtraction. We have multiplication. We have exponent. And there are 2 division operators: the normal division operator and the floor division operator. Last is the modulus, which is a percent sign. I'm going to run, and we know 10 minus 3 is 7. 10 times 3 is 30. And this here will be 1,000, because it would be 10 times 10 times 10. And this here division, there will be 3 and some decimals. And this here will be just the whole number of 3 divided by 3. And this here will be 1, because 10 divided by 3 is 3, and the remainder is 1. I'll talk about it again. Okay, so we see subtraction is 7. Multiplication is 30. Exponent raises 10 to the power of 3, then return 1,000. That's 10 times 10 times 10. We have those 2 division operators. The normal division operator shows 3.3 with 5 at the end. And the floor division operator is also known as an integer operator, because it only returns the whole number. That's why we don't see a decimal. So 3 divided by 10 divided by 3 is 3. It does not include the decimal. Now, the last value is the modulus. That's when we divide one number by another number, then return the remainder. The remainder of 10 divided by 3 is 1. For all of these arithmetic operators, we also have augmented assignment operators. An augmented assignment operator is also known as a shortcut operator, because it combines one operator with an assignment operator. For example, the first row shows a plus symbol and an equal symbol. There's a total of 13, but these are the main ones we just went over. We can also combine strings using an augmented operator. In the IDE, we have course equal to Python step by step. On the next line, I would write course equal to, plus equal to, and the value will be tutorial. When I print course, we're going to see Python step-by-step tutorial. Do you see what happened? It combined the first value with the second value. It's the same with addition operator and the other arithmetic operators. Now, we can write for addition, let's say 10 plus 5. We can write the print statement for addition. The interpreter will add 10 plus 5, which is 15, then assign 15 to the addition variable. Let's run. And as expected, the console returns 15. The long way of incrementing this statement by 5 is to write addition equal to addition plus 5. This is the long way. Now the shortcut of incrementing by 5 is to write addition plus equals 5. It's the same process. Now I'm going to print. And when I print, we know this statement is 15. Incrementing by 5 will be 20. And the last value would be 25. So I'm going to print addition and print addition again. Then run. And yes, we see it incremented by 5, 15, 20, and 25. There's something else I want to show you. It's the order of operations, also known as operator precedence. In math, it's called PEDMAS. Let me go to the next one. It's called PEDMAS, which is PEDMAS. That's parenthesis, exponent, divide, multiply, add, and subtract. It provides the order of how our program will execute the arithmetic operators. For example, let's say result is, what's a good number? 21 minus 1 times 10 plus 10. Looking at this statement, a person might think we solved this problem starting from left to right. But using PEDMAS, we begin with the parentheses. And that's equal to 20, 10 plus 10. Then multiply by 1. 20 times 1 is 20. Now we have 21. 21 minus 20 is 1. So when I run, the console shows 1. Good. That's it for assignment and arithmetic operators. Next, I will show you comparison operators. Thanks for watching, and I will see you in the next session. Cool. In this tutorial session, we are going to discuss two operators, comparison and logical. Here is a list of 6 operators. First is the equality operator, which is an equal sign for equal to. Then we have the inequality operator for not equal to, followed by 4 more operators. The greater than operator, greater than or equal to operator, less than operator, and less than or equal to operator. Each of these operators are used to compare 2 values, then evaluate both values. After evaluating the values, the interpreter will return true or false. In the IDE, we can write print, then compare our values such as 10 and 5. The comparison operator is placed in between both values. Something I learned from my kids with their homework, helping them, alligator eats the bigger number. The comparison operator is the alligator. 10 is a bigger number. Therefore, this statement is true. Run, and bingo, we see true in the console. Let's compare some more values. How about print 12 is greater than or equal to 34. Print 1 is less than 1. Print 15 is less than or equal to 15. We can also compare strings like print Python is equal to Python. Also, let me put that back. Print Python. My typing is not going good this session. Python does not equal to Python. Okay, so now let's run. The console returns true, false, false, true, false, true. So we already covered 10 is greater than 5. So that's true. Next is 12 is greater than or equal to 34. And the console returns false. The alligator is eating the smaller number. That's why we see false. Next is 1 is less than 1. That's false because they are equal to each other. So 1 is not less than 1, it's equal to 1. 15 is less than or equal to 15. We see true because 15 is not less than 15, but it is equal to 15. So that's why we see true. The strings show false and true. The first set is false because they are not equal to each other. Python on the left has an uppercase P, while Python on the right has a lowercase p. Now, the second set of strings return true because they are not the same. Have you noticed something? The difference between 2 equal signs and 1 equal sign. Start out, it can be confusing because in math, the equal operator means equal to, but in Python, 2 equal signs means equal to. What helps me to not get confused is 2 equal operators in Python are comparing 2 values and asking if they are equal to each other. That's it for comparison operators. Now let's take a look at the logical operators. The purpose of a logical operator is to combine more than one expression. We can also say one conditional statement. There are 3 logical operators: and, or, not. And returns true if all statements are true, or returns true if one of the statements is true. Not returns the opposite. If the result is true, then not operator returns false. That's interesting, and I'll show you. In the IDE, we can print 100 is greater than 50, and 100 is greater than 34. The interpreter will evaluate from left to right. First, is 100 greater than 50? Yes, so that's true. And is 100 greater than 34? That's also yes. Therefore, both statements are true. So the console returns true. If I change one of these comparison statements, like 100 is greater than 50 to less than 50, then the result is false. As a result, we see false in the console. It's false because both of these statements must be true. For the or operator, only one of these statements must be true. For us to see true, we will run. And bingo, the console shows true because the value that is true is 100 is greater than 34, although 100 is not greater than 50. Now, I have something else to show you, and that's the not operator. The not operator reverses the result. However, at this point, we have to be careful because our code can be confusing. For example, if I write not in front of 100 is less than 50, someone may think the code is referring to the complete expression, but it's only referring to 100 is less than 50. To refer to the complete statement, we must add a parenthesis in front of 100 and at the end of this statement. Now it's comparing 100 is less than 50 or 100 is greater than 34. So the code is saying this: is 100 less than 50 or is it 100 greater than 34? After running the previous statement, we saw true. Therefore, this statement will return false because not true is the same as false. Run. And bingo, we see false. Let's do one more statement and make it a little complex by adding and. 100 greater than 95. Do you have an idea what the console will show us? The not operator is referring to 100 less than 50 or 100 greater than 34. 100 greater than 95 is separate. For the and operator, both conditions must be true. They are not true, so the console shows false. That's it for comparison operators and logical operators. Thanks for watching. Don't forget to connect, follow me, and subscribe. Plus, click the bell icon, and I will see you in the next session. In this tutorial session, let's discuss the Boolean operators. A Boolean operator represents two values, true or false. It evaluates a condition, then returns a value. The identity and membership operators are two types of Boolean operators. An identity operator is used to compare two objects, and the membership operator is used to test whether a value is found in a sequence. We see identity has is and is not. Is returns true if the objects are the same, while is not returns true if the objects are not the same. The membership operators are in and not in. In returns true if a value is specified in a sequence. Not in returns true if a value is not in a specified sequence. Let's start with the identity operators. Our objects are address underscore 1234 and address underscore 1238. The values will be inside of a list. First will be red, black, and white. I'm going to copy and paste so they have the same value. These two data types are a list of strings. If I hover address 1238, we see list with str inside of the brackets. It's a different data type than what we discussed in our previous video, comments and data types. The purpose of a list is to store more than one item in a memory address location. We see the same values are stored in a different object. Therefore, if I print address 1234 equal to address 1238, we expect the console to return true because they have the same value. Now, as expected, we see true. When it comes to an identity operator, we are comparing the objects and not the values. Therefore, if I change equal to is, they have the same values, but they are different objects pointing to a different address. Since they are pointing to a different address, they are not the same. So when I run, we see false because the objects are not the same, even though they have the same value. Imagine two houses that are located right next to each other. They look exactly the same, but have a different address. One address is 1234, and the other address is 1238. Although they look the same, they are not the same because they have a different address. If I write the ID function, which returns the address of an object, hover the ID function, and we see it returns the identity of an object. This is guaranteed to be unique. Pass in address 1234, then print. When I print the ID for both objects, you will see that it will have a different address. Let's run, and the console shows a different value for each object. We see one of them ends with 7728 and the other one ends with 8240. Now, I'm going to copy and paste this identity operator and change it to be is not. Run, and we see true in the console because both objects are not the same. Now, we can make both objects the same by assigning one object to the other object, like address 1234 is assigned, the value is assigned address 1238. So now when I copy these other print statements and I paste them and run, look what happens. We see now they both have the same address memory location for both objects. That's it for identity operators. Now, let's take a look at the membership operators. Membership operators is a little different because we know they test whether a value is found in a sequence. So our variable will be message equal to I like Python. The sequence can be a string or it can be a list. We can test by writing something like print Python, followed by a membership operator, end. Is Python end message? Yes, Python is in the message. So when I run, the console returns true. The membership operators are case sensitive. So if I write print Python, not in message, we see true in the console because Python with a lowercase p is not in the string I like Python, because I like Python has an uppercase P. Thanks for watching. That's it for Boolean operators, identity, and membership. Don't forget to subscribe and click the bell icon. Also connect with me on LinkedIn, follow me on Twitter and Facebook, and I will see you in the next tutorial session. In this session, we're going to work with numbers. For Python, we can convert numbers or use a function. Let's start by converting a number to a string. If we want to concatenate an integer, such as cost of water, that is assigned 3, we can print the value but need the string form. For example, print water cost, then the variable cost of water plus dollars. Do you see how cost of water has a brown background? That is because there is a problem. Run and the console shows type error, can only concatenate str, not int, to str. This exception has two parts. First part is the type of error, and the second part is the message. Type error means there is a data type mismatch. The message is saying we can only concatenate string to string and not use integer. We must convert the integer to a string. You know how a number can be an integer or floating point? A similar exception shows up if we update cost of water from 3 to 3.25. Run again. The console returns not float. We convert the value to a string by passing in cost of water to str. Str is the string function. This time in the console, we see water costs $3.25. The int and float function help when converting a string to a number. Whenever we use input, Python makes all of the information a string. So if I write, how much does candy cost? The information inside the quotes is a string. Also, the information we type as a user will be a string. Assign this value to price. Watch what happens when I print price. There is no error, but what if we need to calculate the price? Then add a text. There is an error that's going to show up because 08 has a brown background. It's the same as the previous error about string to string, not float. Bingo, we see not float. Now we convert to a float by passing in price to a float function. Now it's all good. We can calculate price by adding text. Let's run and see what the console shows. 1.07. Converting to an integer is the same, but returns an exception if we are not passing in the correct data type. For example, I'm going to erase this and write number and assign number to 12.97, but place 12.97 inside the quotes. This is a string value, but we cannot convert the floating point number to an integer. So if I write print int and place number inside int, then run, we see value error, invalid literal for int method with base 10. Value error is the type of error, meaning it is the right data type, but the value is inappropriate. The message, invalid literal for int with base 10, means the int method will not allow us to pass in a floating point number represented as a string. We can keep the value in quotes, but it has to be an integer like 12. Run, and we no longer see the error or the exception. We can also change the value to from a string to a floating point number. By changing the floating point, we convert this to 12.97. Remove the quotes, then add back 97. Run, and the console only shows 12, which is the whole number. There are more math functions that we can use with our numbers. We can also use round. The purpose of round is to return the nearest integer value. Just replace int with round and the console shows 13 because it round up. We can also use ABS. This is short for absolute, which returns the absolute value of a number. It always returns a positive number. If I make this a negative 12.97, then play, we see 12.97 as a positive number because 12.97 positive is the absolute value of negative 12.97. Now, we can also use another function like POW. This is POW, and it returns two arguments. The first argument is the number like 10. The second argument is a number like 3. This reads 10 to the power of 3. The answer should be 1000, just like our arithmetic operator accession when we use exponent to calculate 10 to the power of 3. Now I'm going to run after I print. The console shows 1000 as we expect. Another function we can use is min. The purpose of min is to return the smallest argument. It will return the smallest of these two numbers, 10 and 3. The console returns 3 because it is the smallest number. We also have max, and that's the opposite of min, and it will return the largest of 10 and 3, 10. In addition to these functions, we have some complex functions from the math module. The math module allows us to access reusable functions from math. After we import this statement, brings in outside code to our file so we can perform a math operation. You can find a list of operations online. For example, I'm going to erase max 10.3 and write sqrt and place in 25 inside the function. This is the square roots function. It returns the square root of a number. Square root is the value of a number multiplied by itself. The square root of 25 is 5 because 5 times 5 is 25. The console shows 5.0. That's it for working with numbers. Thanks for watching, and I will see you in the next session. In this session, we are going to look at Python if-else statement. An if-else statement allows our program to make a decision based on a condition. The condition evaluates to true or false. We can execute some code when the condition is true and other code when the condition is false. In our IDE, the condition is if you are 18 years old or older, the program will print confirm you can vote, then go vote. If not 18, then the program will print sorry, but you are not old enough to vote. Please come back when you are 18 or older. Our program will respond to the condition depending on the age. Let's start by writing a basic if statement. I'm going to type age, and it will be assigned the input. What is your age? We want to receive an integer, so we place int in front of the input function. I can write an if statement to check if the value of age is greater than or equal to 18. Now, age greater than or equal to 18 is the condition. It will return true or false. Make sure to add the colon, then enter. Notice how the next line is indented with 2 spaces. That's because Python relies on indentation to determine the scope. The scope includes everything indented under the if statement. Therefore, it will be executed when the condition is true. For example, if I write 3 print statements, 2 print statements under the if condition, print, print. The third print will be on the next line, but it will not be indented. So for the first print statement, I'm going to take this value, confirm you can vote, in double quotes. And for the second one, I'm going to just write, copy and paste, then go vote. For the third print statement, I'm going to add, have a great day. It is not indented and does not belong to the if condition. That means it will print every time since it is not part of the if condition. Let's run. How old are you? 18. Confirm you can vote. Then go vote. Have a great day. Let's run again. This time, 14 is the age. Have a great day. And we still see have a great day because it's not part of the if condition. We group the Python code into blocks. A block starts and stops with the indent. So we must be careful how we indent our code. The next keyword is else with the colon. This helps our program to make a decision if someone is not 18 or older. Every statement indented under the if will be executed when it's false. If not 18, then we're going to print 2 more statements. The first statement is sorry, but you're not old enough to vote. And the second print statement is please come back when you're 18 or older. Now, I'm going to run, but at this point, we have satisfied both conditions. When the condition is true, Python will execute our print statements under the if statement. When the condition evaluates to false, then Python will ignore the print statements under the if statement, then execute the print statements under the if statement. Now, I'm going to run, and let's see what happens when I enter age as 15. Sorry, but you're not old enough to vote. Please come back when you are 18 or older. Have a great day. Run again. This time, the age is 81. Confirm you can vote. Then go vote. Have a great day. So that works as expected. I have a shortcut for the if-else statement. It's called a ternary if statement. Rewrites the variable outcome. Then a value like true. True is a Boolean value that will be followed by a condition. The condition is if age is greater than or equal to 18. The purpose of a ternary if statement is to make our code concise. Now, so far, our statement satisfies the true value if age is greater than or equal to 18. Else, false. We must make the Boolean value inside a print statement a string. So I'm going to write, can you vote? And I'm going to write the plus to append the outcome. But notice how the outcome is brown, like we mentioned in the working with numbers video. But this here's a Boolean statement for true or false, but it's still not a string. So I'm going to add the string function to make true or false a string and run. What is your age? The age this time, will it be 34? Can you vote? True. Confirm you can vote. Then go vote. Have a great day. Run again. 12. Can you vote? Is false. Sorry, but you're not old enough to vote. Please come back when you are 18 or older. Have a great day. That's it for if-else statements in Python. Thanks for watching, and I will see you in the next session. In this session, let's discuss the if-elif else statement. Elif is short for else if. It provides another condition statement that our program checks when there are more than two conditions. Recall from the previous session, the if-else statement allows us to check for only two conditions. We can add as many elif statements that we need in our program because we may come across a scenario that have many scenarios. For example, here is a list of 4 scenario conditions. The first condition says if the price is greater than $100 and less than or equal to $199.99, then the customer gets a $10 discount. The second condition, if the price is greater than $200 and less than or equal to $299.99, then the customer gets a $25 discount. Third condition, if the price is greater than $300 and less than or equal to $399.99, then the customer gets a $50 discount. Fourth condition, if the price is greater than $400, then the customer gets a $60 discount. We need a block of code to handle all of these scenarios. Let's start with input. Enter cost of items. Let me move this up some so we have more room. The value we expect will be a float. So we add the float function before the input function. Then assign the value to price. Please follow along and write your code as I write my code. Now, our program will check if the price is less than $199.99. When the price is less than $199, then the discount will be assigned $10. The purpose of an elif statement is to provide another condition when the if statement is false. So our second condition is elif price less than $299.99. Then discount will be assigned $25. Always type the colon. The colon means we are starting a block of code that will be executed when the condition is true. That's why our program has an indent. Be careful, because if I decrease the indent by 1 space, an error will show up. Python is strict on indents. The third condition is elif price is less than $399.99. Then discount is assigned $50. The elif statement is like an if statement. However, it is only evaluated when the if statement is false. When the if statement and all of the elif statements fail, then Python runs the else block. We have a discount of $10, $25, and $50, but the only discount remaining is $60. There is a $60 discount when the price is greater than $400. Python does not require an else statement. We can easily make the else block an elif statement. Now, the else block is a catch-all statement that tests any condition when the if or elif statements that's not included with the if, elif, or if statements. So it's just a way to broaden our test. Now, let's print the discount. Your discount is $. Use the format code for type float. In the string, we write a %, a decimal, the number 2, and an F. The %, .2f is a format description placeholder for a floating point number with a 2 precision. 2 means there will be 2 values after the decimal point. Next is the string operator, followed by the discount variable name. Now, if you read this here, it's going to be 2 decimals after the $. But if I put a 3 here, it'll be 3 values after the decimal point. Now, after the print statement, we're going to calculate total with price minus discount. Last step is to print the total by writing print your total price is. Just like the previous statement, we can just copy it, and I'm gonna put it right here. Bingo. Followed by the modulo operator and total, which is the variable name. Now, let's run. Enter cost of items, 100. Discount is $10 and total price is $90. Next is 250. Discount is $25 with a total price of $225. Let's test for some more conditions like $399.99. Now, the discount is not correct because it shows $50. Now, I want to show you that for the $99.99 because what we should write is less than or equal to, less than or equal to, and less than or equal to. Because if I put less than only, that means that the value that will be true would be $399.98. So make sure that you add the equal sign. That's a good mistake that people make sometimes. Even when we're testing code, a developer can easily forget to put the equal sign. Now, let's run again. And I'm going to add $399.99. Now we see $50. Next is $400 even. And we see $60 because if we think about the condition, if the price is greater than $400, now I made a mistake and it should be greater than or equal to $400. Now, let's do one more thing because it's good to test for many conditions. Therefore, we must think about our code and the possible values before we say it's all good. How about $99.99? Uh-oh, we have a problem because the discount is supposed to start at $100, even if the cost of the items is negative $50. We know that's not right because we still see a discount. In this situation, we will add a nested if statement. A nested if statement is when we place a statement inside of another statement. For this case, we are going to check for a condition after the first condition evaluates to true. So at the top, we add a nested if statement and indent the existing block of code. Indent, and we're going to write if price is greater than $99.99. This condition determines if we execute the remaining block of code. If the condition is true, then the Python interpreter will check if the price is less than or equal to $199.99, followed by the subsequent lines. However, if price is not greater than $99.99, then we add an else block. Now, the else block will only come to an execution if this code is false. So, add the else block, I'm going to add another print statement. And that print statement would say, you do not qualify for a discount. Let's run. Uh-oh, I have a syntax error. And it says if price is greater than 99. So if price is greater than 99, you see what happened? I forgot to add the colon. Run again, and let's add -10. Bingo. We see the console shows you do not qualify for a discount. This time, the cost is $50. And we still see you did not qualify for a discount. Let's double check to make sure we can get a discount. Run, and I'm going to add $150. Bingo. The console returned a $10 discount with a total price of $140.00. That's it for the if-elif and nested if statements. Thanks for watching, and I will see you in the next session. In this session, let's look at when to use multiple if statements and when to use an if-elif statement. Both are important and good for making a decision. To recap, the if-else statement allows us to check for only two conditions. The if-elif statement comes in handy when our scenario has many conditions. In this scenario, let's make a list of available fruits. In the list, we will have oranges, grapes, strawberries. No, before strawberries, let's put apples. then strawberries on the next line. Last will be pineapples. Let's start with multiple if statements by writing if apples is in available fruits, put the colon, then we're going to print add apples to the list. The next print statement will be if grapes in available fruits, then we're going to print grapes, add grapes to the list. The next statement will be if strawberries in available fruits, then we're going to print strawberries, add strawberries to the list. All of these statements are true because apples, grapes, and strawberries are in the available fruit list. Now, let's write if-elif statements. Know what? I'm going to copy and paste the if statements, then replace if with elif. One more time, elif. The code looks almost the same. However, there's a difference. Let's run and see what it shows. I'm going to add \n at the, so it's skip a line. All of the print statements are displayed when using multiple if statements. For the if-elif statement, the console only shows one statement. A person may think we should use multiple if statements, but it depends on the scenario. The if-elif statements are more efficient when we need only one condition to pass. Therefore, it's best to use an if-elif statement when we have more than one condition and only need one to return true. But with multiple if statements, all of the conditions are checked, even when one of the statements is true. Therefore, it's best to use multiple if statements when we need more than one condition to pass. Let's debug and walk through it step by step. Go to run and debug. We see execution stop at if apples in available fruits. The condition is true. At the bottom, click step into F7. So it will print add apples to the list. Step into again, and now we'll add the condition for if grapes. That's also true. So step into takes us to the print statement for grapes. At this point, we see how the block of code for multiple if statements execute every if statement. Step into 2 more times, and we are finished. And execution drops down to the next block of code. At the next block of code, we have the if-elif statements. Watch what happens behind the scenes for if-elif. The condition is true. Step into, and we're at the print statement for apples. Step into 1 more time, and we are finished. Only one block of code was executed when the condition was true. The remaining conditions were skipped for an if-elif block of code. That's why the debug window is disabled. Run 1 more time, and we see the results in the console. The first condition checks to see if the statement is true, if apples is in the available fruit list. Both block of codes are true, so apples are added to the list. The if statement checks for grapes and strawberries. However, the if-elif block of code is bypassed because the apple statement is true. That's it for the difference between if-elif statement and multiple if statements. Thanks for watching, and I will see you in the next session. In this session, we're going to use the match case statement using Python. It has a feature like the switch case statement from other languages, but the match case statement has more features. We must install Python 3.10. This is the Alpha 6 version. You see Python 3.10.0A6. I click the Windows installer to get the executable file in my downloads folder. But the Python part was placed in my programs folder. Now, if I go to my command prompt and type Python, 2 hyphens, version, we still see Python 3.9.2. I have both versions because if I go to my Python folder, 3.10, and type CMD for the command prompt, we see the path location 3.10. Now when I type Python 2 hyphens and version, you will see Python 3.10.0A6, which is both versions that I have on the system. Now, if you want more information about Python 3.10, here's a website you can go to see what's new in Python 3.10. We see new features, parenthesized context managers, better error messages in the parser, PEP 626 precise line numbers for debugging and other tools. But in this session, I will demo PEP 634 structural pattern matching. The description shows structural pattern matching has been added in the form of a match statement and case statements of patterns with associated actions. And here's the syntax in the box. We see more features when I keep on scrolling in this website. Now, when I go to the console, there's something else I must do for Python. In PyCharm, in the IDE, I'm going to go to File, New Project. And you know how I said I had Python 3.9 and 3.10? For the base interpreter, I changed it to 3.10. 3.9 is here and 3.10 is there. And you click Create when you come to your new project. There's one more thing. I went to File, Settings. Right now I'm at Inspections. But if you're not at Inspections, you can search for PEP. And there are 2 entries for PEP8. Uncheck both boxes. If you do not check the box for code and style violation and the naming convention violation, in your editor, you will have those red lines like it's a syntax error, although there is not a syntax error. Your program will still execute, although you have the red lines for a syntax error. But to avoid those lines, just uncheck these boxes. Now, let's write our code by starting with an input function. And the prompt would be enter car name. Then assign the value to car. Next is match car. The purpose of match is to take an expression, then compare the expression value. Car is the variable name that will receive a value. We are going to evaluate car in the match statement. Next is to compare car with the pattern by writing case. double quotes or single quotes, Audi. And let's write the colon, because the colon, if we don't add it, it would be a problem. This is one of the patterns that will be compared with an action of print. Your car is an Audi. If the value is Audi, then the print statement will take action by displaying your car is an Audi in the console. The next pattern is case BMW. Print statement, your car is a BMW. Let's write one more pattern. Case Cadillac. Print statement would be your car is a Cadillac. The variable car will be compared to each pattern from top all the way to the bottom until a match is confirmed. If a match is not confirmed, then we can take two approaches. We can write case with the wildcard, which is an underscore, or a value like unknown. Both approaches is a catch-all statement that would catch any value that's not in the case value pattern. So if it's not in the case value pattern, Audi, BMW, or Cadillac, then it would jump down to this catch-all statement. Let's look at both parts, the wildcard and the unknown, but let's start with the unknown. Print. The action is your curly braces, curly brackets, and I'm going to pass in unknown. Your unknown car is unknown. Did you notice how automatically an F was placed in front of the quotes? That's how we format the string. Let's run. Enter car name, Audi. The console returned, your car is an Audi. Run again. This time I'm going to enter BMW. The console shows your car is a BMW. How about Cadillac? The console shows your car is a Cadillac. For the catch-all statement unknown command, let's enter tempo. The console shows your tempo car is unknown. I like the unknown command. Now for the wildcard underscore, change unknown to an underscore. Then update the print statement to your value is not an Audi, BMW, or Cadillac. And I'm going to remove the F and then run again. Enter car name. How about Camry? Bingo. Your value is not an Audi, BMW, or Cadillac. That's it for the new match case statement in Python using the unknown command and the wildcard. Thanks for watching, and I will see you in the next session. In this session, we are going to focus on Python for loops. A for loop allows us to cycle through a sequence. The sequence can be numbers, letters, strings. It can be a lot of things. The good part about a for loop is how we can automate a repetitive function. In our IDE, we create a for loop by writing for. At this point, we need to define a temporary variable. It's temporary because the variable represents a different value each time our program iterates this for loop. Letter is the variable. N. Now we need to mention the sequence or collection. Let's use a string with Python tutorials. This code line states for each letter in Python tutorials, we are going to take some kind of action. The action we are going to take is print letter. Run, and we see Python tutorials with each letter on a separate line. That's how for loops work. The variable holds one letter at a time. The first iteration was P, and the second iteration was Y. Now, let's use a list. The list can be some names like Jane, Joe, John. Change letter to name. So the code says for each name in names, this will print each name. We see Jane, Joe, and John in the console. For numbers, our sequence can be 1, 2, 3. Run, and we see 1, 2, 3 in the console. However, the best way to iterate a group of numbers is to use the range function. Now, I'm going to change for name to for number and print number. The range function is more efficient because we may have a scenario that have way more than 3 numbers, like 100. When I hover range, the description shows return an object that produces a sequence of integers from start inclusive to stop exclusive. That means the range function would print up to 100, so it would not include 100. Run, and we see 99 as the stopping point with 0 as the starting point. So we see 0 all the way to 99. Recall how the description for range showed it start inclusive. We can add a number like 50 and a comma to start our sequence. Run, and now we see 50 as the starting point all the way to 99. There's one more feature I want to show you with the range function. It can also accept number of steps. So the step tells the compiler what number to increment and decrement. For example, if I write to increment or decrement, if I write 10 after 100, then the for loop will increment by 10. Run, and we see 50, 60, 70, 80, 90. Do you know what the console will show if we count backwards by 10? First, we have to change 50 to 100. So our counter starts at 100, then stop at 50. Add a negative, so it executes backwards. We see 100, 90, 80, 70, and 60. It does not include 50 because 50 is exclusive. That's it for Python for loops. Thanks for watching, and I will see you in the next session. Cool. In this session, let's take a look at while loop. The purpose of a Python while loop is to execute a block of code multiple times. We can add some lines of code, and it will loop through the code until a particular condition is false. Therefore, our program will execute over and over again while the condition is true. In the IDE, let's start with the variable called number and assign it to 1. The while loop has 4 parts. It has the while keyword, a condition, a colon, then the while clause. The while keyword is followed by a condition. From previous sessions, we know a condition evaluates to true or false. Our while clause, which is a block of code, will execute while the condition is true. Let me erase the condition, then write a condition like number less than or equal to 5. The next line begins our while clause. Everything indented below the while keyword, condition, and colon is considered the while clause. Print number. Print number will execute while number is less than or equal to 5. The condition determines how many times the variable number shows up in our console. However, we must be careful and have no infinite loop in our program. An infinite loop is a loop that always evaluates to true. Run, and we have an infinite loop that only shows 1 in the console. If I stop the program, we see process finish with exit code -1. The value started at 1, but it never incremented to 2. We increment by writing number equals number plus 1. This statement takes the value of number, then add 1 to the number. The shorthand is to have number plus equals 1, and it will automatically add 1 to the number. Let's add one more print statement to show when the while loop is complete. Now I'm going to run, and this time we see 1, 2, 3, 4, 5. While loop is complete. Here is the process. Number is initialized to 1. Next is to check the condition. Is 1 less than or equal to 5? Yes. So the condition is true. Therefore, the code says while 1 is less than or equal to 5, print number, then increment number by 1. After incrementing by 1, the number is now 2. At this point, the program jumps back to the while keyword and the condition. Is 2 less than or equal to 5? Yes. So while 2 is less than or equal to 5, print the number, then increment the number. This process will continue until the number is 6. Now, when it increments to 6, the while loop is complete because the condition is false. 6 is not less than 5, and 6 is not equal to 5. If number is initialized to 6, then the condition starts with the false value. As a result, the block of code will be skipped and never execute. Run, and the console only shows while loop is complete. That's it for the while loop in Python. Thanks for watching, and I will see you in the next session. In this session, let's talk about keywords in Python. The focus will be two keywords, break and continue. Both keywords can be used in the for loop or while loop. The purpose of keyword break is to stop a loop. However, the purpose of keyword continue is to start at the beginning and reevaluate the condition. Let's create a list of numbers. There will be assigned 1, 2, 3, 4, 5, 6, 7. We are going to loop through each number using a for loop. Number in numbers. There are times in programming we want to skip a lot of code. Whenever Python see the keyword continue, it will bypass the code. So any lines below continue will not get executed. Our code will skip number 5 by writing if number equals 5. Continue. For all other values, we want to print number. Let's add one more print statement so we know when the loop stops. Print end of loop. Now let's run this code. We see 1, 2, 3, 4, 6, 7, end of loop. We do not see number 5. Let's walk through the code and get into it more detail. Let's add a breakpoint. This time go to run debug. Select keyword break continue because that's the name of this program. Now we see this shortcut for stepping to F7. Click F7. Now it's at number 1. And the line is at if number equals 5. 1 is not 5. So print number 1. I'm going to hit F7. And we see the line moves down to number 7, line number 7, print number. Now I'm going to keep on hitting F7 until number equals 5. 4, 5. Okay, we're at 5. Watch what happens when I click F7. If number equals 5, F7. Now we are at continue. F7 one more time. Then the program moves up to the for loop. It jumped right back up. Do you see how it bypassed printing number 5? If I keep hitting number 7, F7, it will print number 6 and 7. Our program looped through every number 1 through 7, but skipped number 5. The keyword break is different. I'm going to change continue to break. Now, when it comes to continue, this time our program will exit the loop and not print 5, 6, or 7. Let's run. We see 1, 2, 3, 4, end of loop. Let's debug the keyword break. So I'm going to hit run debug. The first value shows 1. Now I'm going to hit F7 and it reached the print statement for print number. Keep clicking F7 and the process will continue until number 5. Now we're at 5. If number equals 5, click F7. Now we're at the break keyword. Our code will break out of the loop, then print end of loop. I'm going to hit F7 one more time, and you see how it bypassed print number and moves straight down to print end of loop. I'm going to keep on clicking F7, and you see what happens. It bypassed 6 and 7. If you wanted to compare the break and continue keywords, I'm going to copy and paste, then change break to continue and run again. Now we see 1, 2, 3, 4 end of loop for the break keyword. And we see 1, 2, 3, 4, 6, 7, skipping number 5 for the continue keyword. The continue keyword shows every number except for 5. Python has a list of keywords that's reserved only for Python. Therefore, we cannot use words that's reserved for Python for a variable name or even for any other kind of identifier. For example, do you see all of the keywords written in orange? For, in, if, break, and continue. Those are keywords. To see a list of the keywords, we can import keyword. And import is also a reserved word. Now, I'm going to print a list of the keywords by writing print keyword dot KW list. And when I run, we see a list of reserved words such as false, true. What else do we see? We see break, continue, elif, else. I also see for, if, import, in, and there are more reserved keywords. That's it for Python's break and continue keywords, plus the list of other reserved keywords. Thanks for watching, and I will see you in the next session. In this session, I will talk about functions. A Python function has a group of statements designed to perform a job. It's a good way to organize our code into reusable chunks. The reusable chunks of code benefit us if we need to update our code and if we need to reuse the code over and over. We have already seen some functions such as print and input. These two functions are built into Python. However, we can also write our own Python functions. Whenever Python sees def, it knows we are defining a function. Def is short for define, and it is followed by a name. The name is our function. Do you recall the naming convention for a variable? Naming a function has the same convention as a variable. We should always have a descriptive name with lowercase letters. If there is more than one name, more than one word, then we separate each word with an underscore. This function name will be greet underscore the underscore user. Cannot forget the colon, which lets Python know we are getting ready to define a block of code. Therefore, any code lines that comes after this first line will be parts of our function. The first line is the function definition. Automatically, the next line is indented after clicking the enter key. The block of code will be print. I'm going to tab and write hello, how are you? And print. Tab again, and then write this is a Python function tutorial. These two lines represent the body. We know it's the body because they are indented. The next line will be print. Start at the top. This line is not part of the function because it is not indented. Do you see the line under our function name? Greet the user. Python is showing this line because it wants to add a docstring comment. It's not required, but when I hover over the line, we see missing docstring and insert docstring. Select insert docstring, then write, this is a Python function example. A docstring explains the purpose of a function. Now, let's run. The only print statement we see in the console is start at the top. That's because execution in Python always skip over a defined function. The defined function only describes our code. If we want to execute our code, we must invoke the function, also known as calling the function, by writing the function name greet underscore the underscore user. If we think about it, greet the user is also the same as when we call print and input. It has a name and parentheses. However, we have to be careful when we place the function. It's very important. We are not allowed to place the function call before the name of the function. If we place it before the function, we get an error. And the error says unresolved reference. So the best way to place the call is after the function name. Now let's add one more print statement. I'm going to write print stop at the bottom. Now let's run. We see start at the top. Hello, how are you? This is a Python function tutorial. Stop at the bottom. Let's walk through the process flow. Like the last execution, our code lines 6 and 7 were not executed within the function. Our program started at line 9 and stopped at line 11. Line 9 says start at the top. Then Python executes line 10, which is the function called greet the user. The program jumps up to the first line in the function, then begin executing the block of code for both print statements. When the program finishes executing the function, then execution return to line 10 that called the function. Finally, the program moves to line 11, stop at the bottom. The print statements within the function were only executed when we called the function at line 10. That's it for functions in Python. Thanks for watching, and I will see you in the next video. In this session, we are going to talk about Python parameters and arguments. Sometimes an engineer may call a parameter an argument and call an argument a parameter. However, there is a difference between parameters and arguments. A parameter is a variable that stores information so a function can perform its job. An argument is also information, but is passed to the parameter when calling the function. Let's use the same example from our last session. What is the difference between Python's built-in print function and our defined greet the user function? The built-in Python function for print contains information, and greet the user does not contain information. Let's investigate the print function. Do you see the values within the parentheses? Those are called parameters. We are going to create our own parameter. The information in green is the docstring comment. If you look at the file name, we see built-ins.py because this complete file contains a list of Python functions. if I search for input, we see that input is also here, and it has parameters. Now let's go back to our file, and we're going to create our own parameters and arguments. Notice all of the print statements have data within the quotes. Hello, how are you? This is a Python function tutorial. Start at the top, stop at the bottom. These are the arguments that get passed to the print function. So now with our parameter, we're going to write name between the parentheses. The purpose of the name parameter is to operate as a placeholder so it can receive information. Recall, an argument is passed to the parameter. We pass information to the parameter from our function called greet the user. James will be the name we pass. After our function receives the name value, we can print James by formatting the name. Place an F before the single quotes, then curly brackets before the comma. Now, this is how we format the name. All we do is place name between each curly bracket. Do you notice that F has a brown background? That's because this Python version does not support the F prefix. It's okay. It won't cause an error. So we're going to continue. And our print statement now says, hello name, how are you? Let's run. And we see the name James was printed to the console. You see how we use the print statement 4 times? 1, 2, 3, 4. If we wanted to, we could also print greet the user more than 1 time, and it would print a different value to the console. Print, and we see James and John. I'm going to remove John. And in the same way, how the print function had more than 1 value for a parameter, we can also add more than 1 parameter to our greet the user function by separating name with the comma and write age as the other parameter. Now, let's add one more print statement for age by writing print, and within this, we're going to write another tab, are you plus age. And we're going to put years old. Let's pass in 34 as the value. Now, let's run. And we see both values in the console, James and 34. At this point, we can reuse the function over and over. That's it for Python parameters and arguments. Thanks for watching, and I will see you in the next session. In this session, we're going to focus on default values for Python. It allows us to define a function with a default value for each parameter. We are required to have an argument if the function has a parameter, unless we have a default value. Right now, we have 2 parameters, name and age, with 2 arguments, James and 34. If I remove age, 34 as the argument, the parenthesis has a brown background with the note that says parameter age unfulfilled. It will not be a problem when adding a default value to the age parameter. Age equals 38, and the brown background goes away. Our program will use the default value when we do not provide an argument. Run, and the console shows, are you 38 years old? The program provides a warning message if we use the same default value and argument value. For example, if I write name equals James, the argument has a line that says argument equals to the default parameter value. It's just a warning, so if I run this program, it will not show an error. Look what happens when I add 34 back as the argument, then remove the default value, age equals 38. We see an error for the parameter. And it says non-default parameter follows default parameter. To fix this problem, age must have a default value if name has a default value. We are not allowed to have a parameter without a default value following a parameter with a default value. However, it's not a problem if I make age equals 38, then remove name equals James. Run, and the console shows James as the name and 34 as the age. The program uses our argument value. When we have an argument and default value, that's why we see 34 and not 38. Let's add John as the default value. Then remove both arguments. Notice we do not have an error. Run, and the console shows both arguments. They show both default values, John and 38. Yeah. That's it for default values for Python. Thanks for watching, and I will see you in the next session. In this session, we are going to look at two Python concepts, positional arguments and keyword arguments. A positional argument depends on the parameter order. Each argument must be in the same position as the parameter. The keyword argument happens when we pass a name and a value pair to a function. Starting with the positional arguments, let's remove these default values, John and 38. Then add back one more argument. The name argument will be Jane. From the last session with default values, we know this is a problem because there is an age parameter, but no age argument. If we do not want to include an age argument, then we must include a default value. Let's run, and the console shows missing one required positional argument, age. Another problem is how we sort our arguments. In order, the parameters are name, then age. So our arguments should also have name before age. But if I write 18 before Jane, then the console will swap the values when I run. We see, hello 18, are you Jane? That's not right. So for positional arguments, our program expects the arguments to be in the same position as the parameters. However, the position does not matter if we use keyword arguments, because a keyword argument is based on the key and value. The key is the name of the parameter. Age is the parameter, so that will be our key. Also, name is the parameter, so it will be our key. The values are 18 and Jane. Now, when I run this time, the console shows, hello Jane, are you 18? Make sure the key is spelled just like the parameter. If I misspell name and have the arguments for the argument, we see it's a problem. When I hover, we see unexpected arguments. It does not recognize NAM. Let me show you one more thing. We would not on purpose misspell name and have the arguments out of order, not on purpose. So when I do this here, by putting it in the correct order, name before age, and adding back the E, there is not a problem. But watch what happens when 18 is by itself as a positional argument after removing age equals the key. The error says positional arguments after keyword arguments. On the other hand, it's not a problem if the second argument is a keyword argument and the first argument is a positional argument. Just remove name equals. There is no error. But now I'm going to add back age equals. And it's not a problem when the keyword value is the second argument. Now when I run, there is no error and the console shows each value in the correct place. Hello Jane, are you 18? That's it for Python positional arguments and keyword arguments. Thanks for watching, and I will see you in the next session. In this tutorial session, we're going to focus on returning a value from a function. A defined function can process information, then send back a value to the calling function. The value is sent back using a return statement, and the value is called a return value. First step is to create a defined function with the name like add underscore numbers. At this point, Python allows us to set the amount of parameters for our function. The purpose is to provide how many values to send to this add numbers function. Our parameter will be number. We're going to add number plus number. Now, when it comes to this function, it will be adding a number by itself, number plus number. Now, let's call the add numbers function, then pass in 5 as the argument. Also, print the value. When we run, the console shows none. None is a reserved keyword that serves as the absence of a value. We see none because our defined function does not have a return keyword before number plus number. This line is a return statement which consists of a return keyword and a value or expression. Number plus number is an expression that will be returned to the calling function. Let's execute. And this time we see 10 in the console. The reserved keyword also shows up if we forget to add a value or an expression. Remove number plus number, then run. We see none again in the console. Like the parameters and arguments tutorial session, we can also use our defined function to accept more than one parameter. The parameters will be number 1 and number 2. Let's also add total equals number 1 plus number 2. Battery running low. Let's return a value and not an expression. The value would be total. Now, when we run, we're going to call this number 1 parameter and number 2 parameter, but we're going to leave 5 as the number 1 argument and 10 for the number 2 parameter, and 10 will be the argument. We must be careful to not generate unreachable code with a return statement. Unreachable code is also called dead code because the program will never execute that code. After the return statement, we write print the total is, then run. All we see is 15. Hover this print statement, and it says this code is unreachable. Move the print statement before the return statement, then run. The console shows the total is 15, but 15 is on a separate line. Let me show you how to print 15 on the same line using a keyword argument. Do you recall in one of the previous sessions when we investigated the print function, built-in print function? Okay, so it has parameters as SCP and END, end. The docstring comment shows SCP is a string inserted between the values, default a space. If we insert a comma, then a comma will be inserted between each value. However, end, END, is a string appended after the last value, default a new line. Let's go back to our program. Then add a comma, END equals empty quotes, empty value. This will no longer insert a new line. One more concept I want to show you. Right now, we are calling the function with print add numbers. If you want to, you can store the return value by writing a variable like result equals add numbers 5, 10. We would get 15 from the defined by adding 10 plus 5. Next, the total 15 is returned to add numbers 5, 10. Now, when we store the result into a variable, let's print the result. Execute. The total is 15 on the same line. That's it for Python, return values and statements. Thanks for watching, and I will see you in the next session. In this tutorial session, let's talk about exception handling. The purpose of handling an exception is to locate an error, handle the error, then continue running our program. Up to this point, our program stops running when it encounters an error. In the IDE, let's start with a variable called number. Then prompt input from the user. 100 divided by number. Enter a number. We want a value after dividing 100 by a number. Next, let's print the value. Also, tell the user, thanks for your input. One more thing. Let's also take the number and convert the number to an integer by writing the int function. When I run, enter a number, how about 10? The console returns 10 and thanks for your input. This time, watch what happens when I enter TEN. We get a traceback. A traceback includes information about the exception. The exception is a value error. I enter 10, which is a string, but the program expects an integer. That's why the console shows invalid literal for int. Notice two things. Number one, both print statements did not show up. And number two, the exit code is 1. 1 means there is a problem. We do not see the print statements because the program stopped running after the input function. Enter a number. In the program, the print statements on lines 4 and 5 should print the value, then print thanks for your input. However, the program returned an exception because we did not handle the exception. We handled exceptions in Python by using try except blocks. A try except block has two concepts. First, it asks Python to do something. Then it tells Python to do something. Ask, then tell. First, it asks Python to try and execute our code. Then tell Python to raise an exception if there is a problem with our code. For example, we want to try and execute the first 3 lines. Get input from the user. Divide 100 by a number, then print the value. To perform the first concept, we write try and a colon before the 3 lines. Then indent the 3 lines. For the second concept, we use the keyword concept. Keyword except, except. And don't forget the colon after the 3 line. Now we want to perform a command. Let's just add a print statement with the message that says invalid number. Notice there are 3 print statements. 2 of the print statements are indented and 1 of the print statements is not indented. For the first indented print statement, it's a part of the try clause. The second indented print statement is part of the except clause. And the third print statement is not indented. It's the last print statement and it's not part of no clause, but it will execute each time. It shows how execution continues running after coming across an exception for an invalid number, and it shows what happens when not coming across an invalid number. Try except blocks are good for recovering from an exception that we anticipate to happen. If there is not an error, then Python skips the exception clause. So when I run and enter 10 again, we see 10 and thanks for your input. But when I run and enter the same string, TEN, the console shows us invalid number. Also, the print statement, thanks for your input, although there was an exception. We cannot divide 100 by TEN. Exit code shows 0. Do you see the line under except? That's too broad. So the message says too broad exception clause. Python prefers a detailed exception handler like the value error, and the line goes away when I enter value error. Now, after the exception, we see the line goes away, but also we can make the print statement more detailed by adding invalid number, enter a numerical value. So now when I run and enter a string like ONE, the console shows invalid number, enter a numerical value. The message provides more detail and lets the user know what to do. What if by mistake a user they want to enter 20 but forget the 2, so they only have 0 as their number? We see a different traceback. 0 division error is the exception. It shows up because a number cannot be divided by 0. The previous exception for value error did not match 0 division error, so the program stopped running. If I hover except, we see the except clauses specify one or more exception handlers. Therefore, we can add one more except clause for 0 division error. In fact, we can add many exceptions as we need to. So before the last print statement, we write except 0 division error. It's optional, but we can also add a variable after the exception name as EX. It can also be EXC because it's a variable, so it doesn't matter what we name this EXC. Don't forget the colon. Let's print EXC. Now, EXC will return division by 0 if there is an error. Let's also add another print statement so it's more detailed. Print invalid number, number cannot be 0. If there is not an error with the code inside the try block, then Python skips over each excepts block. Now, if there is an error, then Python look for an except block that matches the error, then execute the code. Let's run, and number is 0. The console shows division by 0, which comes from the variable EXC. Invalid number cannot be 0 is our customized message. Enter another number like TWO2. We see a different message, invalid number, enter a numerical value. We see how the try except block handles exceptions. If we enter a good number like 5, then we see 20 and the print statement, thanks for your input, which prints every time when handling an exception. That's it for handling an exception using Python try except block. Thanks for watching, and I will see you in the next session. In this session, I will introduce classes, objects, and instances. Classes and objects help make our program more organized, powerful, and easy to reuse. We create a class to represent people, places, and things. A class represents a condition of the real world. An object is based on a class and use the class as a blueprint to create an instance. Therefore, each object is automatically supplied the same attributes and methods of a class. Create an object from a class is called instantiation, and we work with instances of a class. To create a class, we write the keyword class. So far, in the previous sessions, we have covered some basic data types like int, string, let me spell that right, float, and Boolean. Python also offers some data structures like a list. However, not all data falls under these basic data types. These are built in. As a result, Python allows us to create our own data type using a class. For example, a dog or a cat does not have a representation in one of these built-in data types. So to create our own data types, let's say we have an employee And to represent an employee, that means our class will be called employee. And I cannot forget the colon. Notice employee starts with a capital letter. By convention, the name of a Python class begins with a capital letter. If you had a class that you wanted to leave empty, then we write pass. The purpose of pass is to let Python know you want this class to be a placeholder for future code. It helps to avoid getting an error. For example, if I comment pass, then write emp1 equals employee, then run, we see an error. If I remove the comment, then run again, now we do not see an error. Exit code shows 0. Now we see a line under employee. There's a line under employee because I have not added a doc string. It's missing. The doc string is not required, but it describes the class. I will add a class for an employee's information. Sometimes there's confusion around objects, classes, and instances. The employee class is a template for the employee object. The employee object is assigned to the instance employee1. For example, name equals Joe Doe. Joe Doe is assigned to name. It's the same with objects. Employee1 is not the object, but refers to the object. I'm going to remove name equals Joe Doe, and we see employee1 is an instant variable and created when we instantiate the employee object. That's why we say employee1 is an instance of the employee class. You know how a company can have more than one employee? We can also create more than one instance of an employee by writing emp2 equals employee. Now we have two instances that refer to the employee object. At runtime, the employee object allocates memory for employee1 and employee2. Let me show you when I print emp1, and print M2. Run, and the console shows different memory locations. It shows different memory locations because the employee object has memory for two instances. That means the employee class will return an instance or reference to employee1 and also return a reference to employee2. To verify they are instances of the employee class, we can write is instance, then pass in two arguments, the instance employee1 and the class employee. Also print. I'm going to copy and paste and do the same for employee2. Now, when I run, we see true 2 times. True means they are instances of the employee class. That's the difference between a class, object, and instance. To recap, the class is a blueprint for the object. Therefore, an object has a copy of all information from the class. That information is called attributes and methods. We only access attributes and methods when creating an instance. In this example, the employee object encapsulates all of the information from the employee class, then allow employee1 and employee2 to access that information. Next, I will create information and show you how to access that information. Thanks for watching, and I will see you in the next session. In this session, I will continue with classes and objects, but show you how to create attributes and methods so an instance can access that information. Employee 1 and Employee 2 are unique instances of the employee class, so they will have their own unique data. From the last session, we covered the difference between classes, objects, and instances. A class is a set of directions for how to create an instance. The employee class instructs Python to create a unique instance representing a particular employee. Therefore, inside the employee class, we define attributes and we define methods. An attribute is a quality or characteristics about a person, place, or thing. A method performs an action on the person, place, or thing. In Python, there is a difference between a method and a function. You will hear some people call a method a function and call a function a method. The difference is a method is connected to a class. A variable plus the dot operator are required to call the method. However, a function is not connected to a class and does not require a variable. Input and print are examples of a function. For our class, let's start with an initializer by writing def, prefix with 2 underscores, init with 2 underscores following init, and we write self as the parameter. The initializer is a special method that operates like a constructor. Python automatically runs this method when creating a new employee instance. The self parameter can be any name like this. However, in Python, we use self as the convention. It's required in the method definition and comes before all parameters. The other parameters will be our attributes, which provide information about the employee. All employees have a name, employee number, and salary. All 3 attributes represent an employee and describe what each employee has in our program. Each piece of information is data about an employee. Therefore, that makes up our employee data type. Now, let's assign each attribute to a variable by writing self.name equals name, self.imp underscore num equal to imp underscore num, self.salary equal to salary. Now, when it comes to the attributes and variables, they do not have to match each other, but it's convention. We can write self equals number, but I prefer them to match each other because it's convention and I just like for it to be that way. Now, we have to create an employee, and when we create an employee, the value that's stored in salary is assigned to the variable self.salary. It's the same process for employee number and name. So it's stored in the parameters and then assigned to the variables. When it comes to a method, it determines what action an employee can do and what we can do with the employee. For example, we can get the employee's information by writing def to define the method. The name will be get employee info, and we put self in the parameter. Let's return the employee name. I'm going to also skip a line by writing \n and also return the employee number by writing employee num. And we're going to put the value inside a string function by writing self.empNum. I'm going to also skip another line. This method has one action, and that's to return the employee name and number. We see self.name and self.empNum are the variables. Any variable that starts with self is available to every method in this class. Self is the only parameter because the method does not require no more information. We are finished creating the attributes and the methods. Now we are going to access the attributes and call the method. First step is to create an employee with a name like John Doe, with an employee number of 1 and a salary of $134,000. When Python read this code line, it will call the initializer method. The purpose of the initializer method is to create an instance representing a unique employee, then set the attributes according to the values passed from the arguments. When the arguments John Doe, 1, and 134,000 are sent to the attributes, then the values are returned automatically and stored in the instance employee 1. It's the same for employee 2. Name would be Jane Doe. Employee number would be 2 with the salary of $150,000. Employee 1 and employee 2 are separate with its own set of attributes and methods. The dot operator allows Python to access each attribute and call each method. We write emp1 and a dot operator, and we see all of the information from the employee class. For this instance, attributes employee number, name, salary, and both methods get employee info and the initializer. It's the same for employee 2. We see the same information. Let's print the attributes by writing emp1, emp1 dot name, comma, emp1 dot employee number, also emp1 dot salary. I'm going to copy and paste this same information for employee 2, then change 1 to 2. I'm going to run, and the console shows each value. Jane Doe, name, 1 as the employee number, 134,000. John Doe, 1 and 134,000. Jane Doe, 2, 150,000. The true is from the last session when we show how both employee 1 and employee 2 are instances of the employee class. When it comes to calling a method, there are 2 ways to call a method. We can use the instance or the class name. The instant variable emp1, then call the getEmployeeInfo method. For the class name, we write employee, then call the method getEmployeeInfo. However, with the class name, we must also pass the instance as an argument emp2, because Python does not know which instance we want to run. Let's print both by writing the print statement before we call the method. And I'm going to run, and the console shows both employees' information, their name and number. That's it for Python classes, objects, methods, and instances. I will see you in the next session, and thanks for watching. In this session, let's compare Python class variables and instance variables. A class variable has the same data for all instances of a class. However, an instance variable has unique data for all instances in a class. I will build on the previous session using this employee class. It's not true for all companies, but some companies give a bonus to their employees. This bonus will be $10,000. Bonus is a class variable, and the instance variables are defined using self.name, self.empNum, and self.salary. Bonus is a class variable because it is defined inside the class but outside each method. Therefore, the class variable is owned by the class and is shared across all members of a class. The members of a class are instances and methods. Let's start by sharing a class variable using an instance. Then I will show you how to share a class variable using a method. We share using an instance by writing each instance imp1 dot bonus and imp2 dot bonus. Since bonus is a class variable, we can also access the bonus variable name by using the class name employee dot bonus. Then print the value for each one, employee 1 and employee 2. When I run, we see the same value for each instance and employee. Let's separate both employees by writing their name and their salary. So I'm going to write imp1 dot name, comma imp1 dot salary, and I'm going to copy and paste, and I'm going to change 1 to 2. Bonus is a good candidate for a class variable because both employees receive a bonus. Anytime we create an employee that will get a bonus, we can also update the bonus for the entire class after initializing the bonus by writing employee dot bonus equal to $15,000. Run, and the console shows $15,000 for both employees. However, we know all employees do not receive the same bonus, so I can't update the bonus for one employee. How about I change employee 2 by writing imp2 dot bonus, then assign a value of $20,000. Now, when I run this time, we see a different value for Jane Doe. Employee 1 does not have the bonus attribute. However, employee 2 has the bonus attribute, but only after updating the value to 20,000. Let's print the dictionary by writing imp1 dot. Do you see the 2 underscores before and after dict? That's a way to see the namespaces in Python. Select it for employee 1 and also for employee 2. And I'm going to do this before updating the value to 20,000 and after updating the value. Let's print the namespaces for imp1 and also print the namespace for employee 2. So when I run this time, we're going to see the console return all of the namespaces. However, the namespaces we see are name, empNum, salary, but bonus only shows up the last time. That's because bonus, which is a class variable, only belongs to the class, but was created for employee 2 when updating the value. This concept is important for the next concept for sharing a class variable using a method. I'm going to show you how to access the class variable using self and the class name employee. There are times when we should use class and other times it's best to use self. Define the method by writing def and the method name, which is add underscore bonus to salary. The variable name would be salary underscore bonus. The value would be an integer. So let's write the int function. Self.salary plus. At this point, to access the class variable, we must use self or the class name employee. If I only write bonus, then an error shows up that says unresolved reference bonus. Let's start with employee.bonus and return the employee name by writing self.name. I'm going to also insert a space by writing \n. Then return the salary plus bonus by writing the string function and write the salary underscore bonus. Okay, I see why it's doing that. Let me concatenate it, append it by writing salary underscore bonus, and also insert a line. Now, the next step is to call the method from our two instances. We can also use employee class, but let's focus on employee 1 and employee 2. So I'm going to write emp1 dot add bonus to salary. And I'm going to also print and do the same for employee 2. And when I run, notice the value for salary plus bonus. We see 149,000. That's because it combines 134,000 plus 15,000. But notice employee 2, it shows $165,000 when combining the salary of 150,000 plus 20,000. 165,000 is not correct. It should show 170,000 and not 165,000. Now it shows $165,000 because I use employee.bonus in the add bonus to salary method. For this situation, it's best to use self.bonus because self allows us to override the bonus value for each employee. Run, and this time we see $170,000. There are cases when we should not change the value. For example, the number of employees in a company should remain the same for a class. Therefore, as a class variable, we write total underscore employees initialized to 0. In the initializer method, we can increase the total number of employees by 1 when creating a new employee. Employee dot total employees, and I'm going to use the shorthand by writing plus equals 1. The init method runs automatically every time we create a new employee instance. John Doe and Jane Doe. Let's print employee by writing the print statement employee dot total employees. When I run, as expected, we see 2 employees. That's it for Python class variables and instances. Thanks for watching, and I will see you in the next video. In this session, we are going to look at inheritance. The purpose of inheritance is to let one class pass everything to a different class. This concept helps with the drop principle, which stands for don't repeat yourself. It helps to reduce code duplication and support code maintenance. Therefore, we do not have to start from scratch when creating a new class. For example, right now, I have a class called employee. The employee class will be our parent class, also known as superclass. It has information that will be inherited by a child class, also known as subclass. The information are class variables, attributes, and methods. The methods are initializer, which is the init method. Also get employee info method plus the add bonus to salary method. A child class is a specialized version of a parent class. Therefore, good candidates for child classes are developers and testers because they are specialized employees with unique skills to write code. When it comes to the drop principle, an engineer not respecting that principle would copy all of this information and paste this information into a new class called developer. But this defeats the drop principle because we should not repeat the same code for a few reasons. But one of the reasons involves a possible update to our code. A requirement may change to make a function such as int to float. As a result, the code would change in two locations and not one location. When I run, we see the value change to a decimal for salary and bonus for John Doe and Jane Doe. I'm going to change it back to int. So the value is a whole number. Plus, I'm going to remove this duplicated code in the developer class and only write pass. In the previous session, I mentioned pass is a placeholder for future code. Let's say we want to create a specialized version of the employee class. To inherit, we write the name of our parent class in parentheses after specifying the child class. The developer inherits the employee class. To verify the inheritance, we start by writing a built-in function provided by Python that is called is_sub_class. We pass in the child class, which is developer, followed by the parent class, which is employee. This statement will return true or false, but it will return true because the developer class is a subclass of the employee class. Yes, we see true. Now, we can write as many subclasses as we need to complete our program. At this point, the developer class will automatically inherit all of the values, such as the attributes, variables, and methods from the employee class, all of the information. Let me demo the inheritance by writing imp1. Now, we already have imp1 for employee. So I'm going to go ahead and erase all of this information from the previous session and write imp1 developer. Do you see self, employee, name, imp num, and salary? That show the relationship and which arguments to pass. Name is developer John. Employee number 1. Salary is $120,000. Also instantiate M2 equals employee. Name employee Jane. Employee number 2. Salary $110,000. Recall the developer class is empty and only have pass as a placeholder. However, developer has access to the employee class by writing imp1 and a dot operator. The dot operator provides access to the variables, attributes, and methods. Notice we see imp num, name, salary, bonus, add bonus to salary, the initializer, get employee info, total employees from the employee class. How about we call the add bonus to salary method? Print the value for employee 1 and employee 2, which are in two different classes. I'm going to write employee 2. And when I run, we see $130,000 for developer John and $120,000 for employee Jane. With inheritance, Python allows us to customize the child classes with more information than the parent class. We initialize the developer subclass with its own init method. Go to the parent class, which is employee, and only copy the init method because there is no need to copy the instant variables. So when I go back to the developer class, I'm going to paste the init method. Now, at this point, we can add another attribute. The extra attribute will be lang, which is short for programming language. Now, create the instant variable by writing self.lang equal to lang. Next is to call the init method from our parent class. There are two ways to call the parent class. One way is to use super, and the other way is to not use super. Let's start by using super as the keyword, parenthesis, dot, followed by 2 underscores, init. Then we're going to add the attributes name, employee, number, and salary. This statement connects the employee class, which is the parent, to the child class developer. Notice our background for the developer instance is now brown. This is an error because we must include another argument since we added the lang attribute. Let's write another argument by writing Python as the programming language. Now the error goes away. We can print lang for Python by writing print employee 1 is a imp1 dot and call lang. I'm going to add another comma, then write developer. When I run, the console shows Python for employee 1 is a Python developer. The next class, let's call it tester. And it will also inherit the employee class. Define this init method by writing def 2 underscores init self. And the attributes will be name, imp, num, comma, salary. Now I'm going to write another attribute called web mobile. Web mobile is the customized attribute for our tester class. Create an instance variable by writing self.web_mobile equal to web_mobile. The other way to call the parent class init method is by writing the class name employee dot underscore init. Now, when we call using the employee class, the parent class name, we must add self. Now notice the difference. Using super does not use self, but employee must use self. And then we can write the attributes: name, employee number, and salary. We generate an instance of the tester class by writing M3. I'm thinking about printing the value. M3 equals tester. And the name will be, how about we say tester James. Employee number 3, and the tester makes $100,000. And we're going to pass in, how about we pass in web for the other attributes. Now, we print the value for web by writing employee 3 is a comma emp 3 dot web mobile tester. Now, when I run, we see employee 3 is a web tester. That's it for Python inheritance. Thanks for watching, and I will see you in the next session. In this session, I will continue from the previous Python session that talked about inheritance. There's a difference between multiple inheritance and multi-level inheritance. When it comes to multiple inheritance, the child class can receive class variables, attributes, and methods from more than one parent class. Therefore, Python allows us to inherit multiple classes. Multi-level inheritance refers to a derived class inheriting another derived class. In other words, it's when a child class inherits a parent class and that parent class also has a parent. I'm going to show you the difference between multiple inheritance and multi-level inheritance, plus demo the method resolution order. Here's a diagram of multiple inheritance. We see the child class at the bottom inherits from parents 1 and parent 2. For multi-level inheritance, we see there are 2 child classes and 2 parent classes. The class at the top is only a parent, while the class in the middle is a child and a parent. However, the bottom class is only a child. In the demo, I'm going to combine multiple inheritance and multi-level inheritance. The IDE has an employee class, which is a parent. Developer and tester are child classes that inherit the employee class. Now, I will create a class called Automation Engineer. The Automation Engineer class will have 2 parent classes. It has developer and tester as the parents. Write pass, so there is no body. At this point, Automation Engineer represents multi-level inheritance that inherits multiple parents. Let me show you the MRO, which means method resolution order. It is the order when Python looks for a method in a class hierarchy. There are 2 ways to see the MRO. The first way, start by writing the subclass name Automation Engineer .MRO. Then print the types. When I run, before I run, notice the order shows developer, then tester. Now, when I run, we see Automation Engineer. Next is developer, then tester. After tester, we see the employee class, which is the parent class. Last is object. Object is the parent class of all classes. Therefore, it will always be last. We know the employee class is the parent. But if I check the MRO, the type will show in the console object. It still shows object, although we did not specify a parent, because object is the superclass of all parents. Now, let me add some methods to show how Automation Engineer inherits from both parents. For developer, I'm going to maximize. And for developer, we write def to define the develop applications method, pass in self. Then return employed to develop. For tester, let's write the same thing, but let's name this test underscore applications, pass in self, then return employed to test. Now, customize the Automation Engineer class by creating our initializer. And to create the initializer, we write def, two underscores, init, then pass in self. Now the attributes, let's just copy those from the developer and tester classes. Name, imp, num, and lang. And I'm going to paste. Now we also need to get the web mobile attributes from the tester class and paste that one. Now we have the option of writing super or the parent class name, like I mentioned in the previous session, to call the super class. I'm going to start with the parent class, which is developer. Two underscores init. And for developer, when we call the parent class name, we must pass in self. And I'm going to use name, imp, num, salary, and also lang. But I will erase web mobile because that's for the tester class. And for this, let's write super. Now in your production code, I doubt if you would write developer and super, mix it like that. You may use one or the other. But for now, I'm going to write name, imp, num, salary, and also pass in web mobile. And when we use super, we do not need to write the keyword self. Before I call each method from the super classes, let me show you how the second way will look up the chain of classes using the method resolution order. You will see how the order in which we declare each parent class makes a difference. If I change the parent class to be tester, then developer, you're going to see how the MRO will also update. Now, we use the second way by writing the help function and pass in Automation Engineer. Print the types, run as expected. We see the method resolution order. The method resolution order shows Automation Engineer, tester, developer, employee, then object. We also see the initializer method defined in the Automation Engineer right here, plus the methods from tester, test applications, from developer, develop applications, and both methods from the employee class, add bonus to salary, and get employee info method. At the bottom, we see data and other attributes inherited from employee, and those are bonus and total employee class variables. Last, let me show you how the Automation Engineer class can call the methods from both parent classes. I'm going to start by writing automation equals Automation Engineer. Name will be Automation Joe. Employee number 4. Salary 105,000. Web mobile, let's write mobile. And the language will be Python. Now, when I use the reference automation and type automation.app, we see both methods. The first method shows develop applications from the developer class. And the second method shows test applications from the tester class. Automation develop applications. Let's also print automation Joe by writing automation dot name. Add a comma, and I'm going to also print the values. And let's do the same thing for the test applications by changing develop to test. And when I run, we see automation Joe employed to develop and automation Joe employed to test. Thanks for watching, and I will see you in the next session. In this session, let's look at polymorphism in Python. Polymorphism is a compound word that means many specified forms. Dictionary.com shows poly stands for many, and morphism is the condition or quality of having a specified form. That's how we get many forms. By default, Python supports method overriding but does not support method overloading. A parent class defines the general method that can be used by all of its child classes. I will place the transcript PDF documents on GitHub. You can follow me on Twitter, connect with me on LinkedIn and Facebook. Also subscribe to my channel. Polymorphism is related to inheritance. In this diagram, there are 4 classes. Employee is the parent, while a developer and a tester are the child classes. From the previous session, we saw how the automation engineer class inherited 2 classes, developer and a tester. When it comes to polymorphism, the automation engineer class and both parent classes maintain the capacity to take on many forms. For example, the automation engineer class can pick up its own behavior plus the behaviors of employee, developer, and the tester. In the IDE, we see all 4 classes. I will show you how the automation engineer class can override the method from its parent class. Right now, there's only one method in the automation engineer class, and that's the initializer method. Also, from the previous session, I created an instance and wrote 2 print statements. Erase both of these print statements. The reason we override a method from its parent class, because the parent class method does not fit what we want to accomplish in the child class. Let's override the get employee info method from employee. At this point, if I call the method by writing automation dot get employee info, we see the IntelliSense shows employee. Watch what happens when I override the method. To override a method in the child class, we define the method with the same name as the method in the parent class. To save time, let's copy and paste the method in the child class automation engineer. Then return another statement for salary by writing salary colon, and I'm going to append the function using string and then pass in self.salary. Also insert a new line. Now, if I use automation.getEmployee again to call the method, then the IntelliSense updates to show automation engineer. Although there are 2 methods with the same name, Python will only focus on the method in the child class because I am using an instance from the child class. Therefore, Automation Engineer will ignore instructions from the employee class. However, the employee class still maintains its own set of instructions. If I create an instance by writing employee equals employee, and the name will be employee ed, employee number 5, and salary will be 100,000. So at this point, the Automation Engineer class has no effect to the parent class employee. So we don't have to worry about breaking anything in the parent class. If I call get employee using the employee instance, if I call get employee info method using the employee instance, we see IntelliSense shows employee. Now, we can perform the same process for developer and tester classes because they both are parents to the Automation Engineer class. I'm going to print employee.getEmployeeInfo and print automation.getEmployeeInfo. And when I play, bingo, the console shows how it's a difference between the child and parent classes. The child class, Automation Engineer, has 3 lines for employee name, employee number, and salary, while the parent employee class has 2 lines for employee name and number. So polymorphism for Python allows us to override a method. The parent class defines a general method that's common to all child classes, then allow the child class to define its own specialized method. Thanks for watching, and I will see you in the next session. In this session, we're going to focus on importing modules and importing functions. Each module is a Python program file containing related information. It can contain 1 or more functions. The benefit of placing a function inside of a module is to separate blocks of code from our main program. That's a way of dividing our code into logical sections. We import existing code from our main program or import built-in code provided by Python. There are different ways to import. We can import using keyword from and keyword import. If you want the transcript PDF document, I will place it on GitHub. Also, you can follow me on Twitter, connect with me on LinkedIn and Facebook. Also, you can subscribe to my channel. Placing our function inside of a module separated from our main program allows us to hide the details of the code. In this module called Module Converters, I have a print statement, a variable, and 2 functions. The functions are yards to feet and feet to yards. They are converter functions. Notice this other module called module main. It is empty, but I am going to import module converters. The purpose of import is to use code from another file. When we import, it will execute all of the code, including the print statement. Go back to this empty file and write import. We're going to import the module converters file. Leave off the .py extension. If I run right now, the console shows import converters module. When Python reads this import statement line, it tells Python to open the module converters file and copy all of the data from modules converters into module main. To call a function or variable, we can write module converters, then the dot operator. The dot operator provides access to each function and variable. That's why we see tutorial, yards to feet and feet to yards. Select tutorial, then print the value for tutorial. This time when I run, we see import converters module. This is a Python import tutorial. The good part about Python, we can specify a nickname for a module, function, or class. I'm going to start over and write import module converters as. The keyword as allows us to rename a module, function, or class. Since the module name is long, let's rename module converters to MC. Now when I write MC, then the dot operator, we still see the variable and both functions. Select yards to feet and pass in 10. 10 represents the number of yards that will be converted to the number of feet. So far, we see how to import the entire module. These two import statements copy all of the data from a module. However, we can also import an individual function or variable by writing from. At this point, we need to write the module name, which is module converters. Then import. Some people import everything from a module by writing an asterisk. However, this is not recommended because it copies all of the code just like the previous two statements. The recommended way is to import one function at a time. How about feet to yards? Now, we do not have to write the module name and the dot operator. We can write feet to yards, then pass in 10. That's all we need because we imported that individual function feet to yards. Also, print the values. The first converter will print the number of feet by converting 10 yards to feet. And the second converter will print, will print the number of yards by converting 10 feet to yards. Let's run. And the console shows 30 feet and 3.33 yards. It's the same. It's equal to each other. We can also create an alias for a function by writing as FTY. Notice there's an error under feet to yards because we must also rename it to FTY. However, I'm going to remove the nickname because it's not descriptive. And erase. And that's how we have feet to yards. Now, in addition, when it comes to individual functions, we can also add many values separating each function by a comma. So if we wanted to add another function, write a comma, and we can select yards to feet. Now, it's the same process if we wanted to import classes and built-in functions for Python. It's the same way as importing modules and importing functions. Thanks for importing, thanks for watching, and I will see you in the next session. In this session, I will demo how to create packages and how to use packages in Python. A package is a way to organize related modules. For example, if we had 3 modules and the modules were called car, truck, and motorcycle, a relevant package name would be called vehicle. Let's go to PyCharm and start by creating a package. There are 2 ways to create a package. The first way is to right-click the directory, Python project, select new, select directory. Then provide a name like vehicle. Right-click the vehicle directory, select new, select Python file, and the name will be 2 underscores, init, followed by 2 underscores. Vehicle is the package with one special init module. The second way to create a package is to right-click the directory, Python project, select new, but this time select Python package. Name the package animals. Notice how the special module init was created automatically when selecting Python package. This special init module has a purpose to inform the Python interpreter that vehicle and animals are packages. If the init file was not available, then vehicle and animals would not be recognized as packages. Normally, we keep the init file empty. I'm going to add 2 more modules to the animals package. Right-click the package, then select new, then Python file. Name is cat. We can also right-click the package, select new, and select file. Name is dog. If we select file and not Python file, then we must add the extension .py to the end of the file name. Now we have 3 modules, a special init module, cat and dog. Add 2 functions to the cat module by defining meow, followed by a print colon, and we're gonna print cat meows. I'm gonna add 1 more function, define jump, if I can spell it right, add the colon, print cat jumps very high. The dog module will also have 2 functions. Define bark, add the colon, print dog barks. 1 more function, name pants, print dog pants after running. Breathe real hard. Now, to demonstrate how to use a package, let's add another module by right-clicking Python project, new, Python file. The name is app. Using a package is similar to modules, functions, and classes. We can write import animals. Whew, my typing. There it is. We can write import animals, but I prefer to start with the keyword from. Next is the package name animals, followed by import, then the module name dog. A comma allows us to add more than 1 module name. I'll go ahead and add cat. So if I write animals and the dot operator, we see cat animals and dog animals. To print meow, we select meow function. If we want to skip writing the package name animals, then we write dog and call the bark functions. We can call a function either way by writing the package name, then the module, then the function, or only writing the module name and the function. Python allows us to go 1 step further by only writing the function name. The import statement still starts with from, then the package name animals. This time, the dot operator provides access to the module cat or dog. Select dog, then import both functions show up. We see bark and we see pants. I already used bark, so I'm going to select pants. We call the function by only writing pants. Of course, we can use more than one function from animals by writing from dot cat import meow, and also import jump. Call the jump function by only writing jump. Throughout the series, I have been using this play button to run each program. The console shows each print statement. However, we can also use the terminal to print something to the console by writing Python and the module name plus the .py extension app.py. Then press enter, and we see the statements in the console. We can also write app.py without writing Python, and we still see the print statements. That's it for creating a package and using a package in Python. Thanks for watching, and I will see you in the next session. In this session, I will discuss working with the list data type. It's a data type that contains multiple values. Therefore, we can put a lot of data in a list. The purpose is to manage the sequential data in a structure so we can keep track of the data. If you're interested in more content, feel free to read the transcript on GitHub or download the source code. Also, like this video and subscribe to my channel. Plus, follow me on Twitter, connect with me on LinkedIn and Facebook. In the IDE, to create a list, we start with an opening and closing bracket. Each value, such as 5, 8, 2, 1, 7, 8, in the list is called an item or element that is separated by a comma. Since there are multiple items, normally we assign the values to a name that ends with an S, like numbers. We can create a collection of items that include numbers, true-false values that are Boolean, and letters like capital A, lowercase a, capital X, lowercase b. Also, it can include names like Jane, John, and James. If the values are related, it can also be a combination of numbers and letters. Python allows us to create a list within a list like Booleans, values that contain square brackets within the square brackets that are separated by a comma. First list item can be a 0, false. Second list can be 1, comma, error. Now, 1, comma, that'll be true, and next would be -1, and that can be error. To print, we pass in the name of the list, such as numbers. Print, how about letters, and also print Booleans. When I run, we see each value in the console for numbers, letters, and the Booleans. Now, we have a function that count the number of items in a list, or how many times an item appears in a list. And that is the len function, which means length. So if we want to see how many items are in a list, we place len before each list name. Len numbers, len letters, and len booleans. Run, and the console returns 6, 7, and 3. Notice how the list within a list shows 3 and not 6. That's because each list is considered one value. However, the len function is different from the count method. The count method returns how many times a particular item is in a list. For example, if I erase these print statements and type print numbers, then dot count, and pass in the number 5, then run, we see 1 in the console. Therefore, the 1 in the console shows how many times 5 appears in the list. Now, if I change 5 to 8, we see 8 shows up twice. So now run, the console shows 2. To access each item in a list, we print numbers, then the square brackets, then pass in the location. Each item in the list has an index position that starts with 0. Therefore, the first item, which is 5, represents index 0. Inside the square brackets, when I write 0 and run, the console returns 5 because it is the first index, the first item, which is index 0. Now, I'm going to pass in another value, but when it comes to 0, we know it's the first index. We can also count backwards, count the last index, and count backwards, we can use a negative number. However, the indexes start at 1 when using an index number. Let's use a different list by changing numbers to letters. Then pass in -1. Then run, and the console shows James because it is the last item in the letters list. Accessing a particular item is different for a list within a list. If I replace letters with Booleans, bingo, then run, we see 1 error in the console because it is also the last item. When I replace -1 with 0, this time when I run, watch what we see. 0, false, because it's the first item for index 0. To access an individual item in a list within a list, we need 2 sets of square brackets for the print statement. And to access that list, let me show you by adding a comment. And we already know that 0 and false is index 0. So for 0, I'm going to write 0, 0. For false, I'm going to write 0, 1. Index position 1 is 1 and true. Therefore, if I write 1, 0, that's for 1. And if I write 1, 1, that's for true. Moving on to the next item, it's the same. -1 is 2, 0. And error is 2, 1. So if I want to print true, I would add 1, 1 in the square brackets. Run, and the console shows true, which is 1, 1. Let's look at a couple of errors for the numbers list. We see there are 6 items. 1, 2, 3, 4, 5, 6. So if I print numbers, then pass in 6 and run, the console shows index error that says list index out of range. It's out of range because the index starts at 0 and the last index stops at 5. Another error for this here is the type error. But let me explain the index error right quick. Python searches this list and realizes there is no index 6. That's why it throws an index error, because it's out of range for 6. But we know that if I pass in 5, it'll be all good for the last number 8. Now, Python only allows integer values for the index position and not float values. Therefore, if I change 5 to 1.0 and run, the console shows type error and does not print the second value. The error says list indices must be integers or slices. Next, I will show you how to slice a list, also demo how to add items, remove items, and sort items in a list. Thanks for watching, and I'll see you in the next session. In this video, I will continue from the last session, which introduced a Python list. The list value is a mutable data type. That means a value can be added, removed, or changed. Recall from the strings video, a string value is immutable, meaning it cannot be changed. The focus of this video will be slicing a list and modifying a list. If you're interested in more content, feel free to read the transcript on GitHub or download the source code. Also, like this video and subscribe to my channel. Plus, follow me on Twitter, connect with me on LinkedIn and Facebook. In the IDE, let's start by slicing a list, which is similar to the range function. We slice by defining 2 integers that will return one value and form a new list. Return more than one value and form a new list. Therefore, I will type 1:5. Index 1 will grab number 8, but index 5 will stop and not print the last item, number 8. I'm going to add a print statement before and after the slice. Print numbers. Numbers. And I'm going to do the same below it. And when I run, we only see numbers 8, 2, 1, and 7. Python prints a slice of the numbers list. The second integer always go up to an index position and stop, but will not include that item. As a shortcut, we can remove one of these indexes or both of these indexes without the second integer. Index 5, the slice evaluates to the end of the list. Run, and this time we see 8. All of the numbers are 8, 2, 1, and 7. The starting index is similar. Without the starting index, then the slice starts at the beginning of the list. If I add 3 for the second integer, which is number 1, and remove the first integer, then Python will automatically start our slice at index 0. Run, and this time we see 5, 8, and 2. Now, let's modify the list by changing, adding, removing, and sorting the items. To change a value, we write the list name like letters, square brackets, then the index number 6. 6 is the last item value for James. Assign a new value like Janice. Print letters 2 times. Now, the updated list shows Janice. There is more than one way to add an item to a list. We can insert, append, and extend. To insert, we write numbers dot insert. Insert takes 2 parameters. The first parameter is the index where we want to add the item. How about position 1? Now, the second parameter is the value we want to add, and that is 34. I'm going to print numbers 2 times. Run, and the console shows 34 was inserted at position 1. The other items get pushed to the right of 34. If we want to add an item to the end of our list, we can use the append method. Write letters. Now, when I write letters, I'm going to also print it before and after the append method. Now, the letter we want to append, or the name I'm going to append, is Jackie. Run, and the console shows Jackie. The append and extend methods are similar and can be confusing. Both methods add to the end of a list. However, it's best to use append when adding one item and extend when adding more than one item. Let me show you the difference. We see how append displays Jackie at the end with one item. Watch how extend operates. Now I'm going to run, and we see how the console shows each letter as one item. Watch what happens when adding more than one item. Let's say we have another list called letters underscore 2. And I'm going to pass in some values like Jackie and Joe. To extend, we write the letters or the list name, letters 2. Then run. And we see Jackie and Joe are added to the end of the list. That's good. However, when it comes to append, when I run, Jackie and Joe are still added to the end of the list, but look how it's added to the end of the list. It's added to the end of the list by looking like a list within a list, just like the Boolean list of values. We prefer not to have a list within a list, but have each individual name. Let me show you why. Add one more print statement to this at line 10. And I'm going to return letters. And I'm going to pass in 7. And then run. And the console shows the complete list and not just Jackie, which is Jackie could probably be number 7, but it shows the complete list. That's why it's best to use append for adding one item and extend when adding more than one item. I'm going to erase all these print statements, or just this print statement. And let me show you about remove. Letters dot remove, then pass in a value like X. Run, and the console does not show the letter X. It was removed from the list. If you know the position of an item, then you can use the del statement, then write the name of the list, which is letters, open and square brackets, and pass in 0. and run. And we see the capital letter A was removed from the list. Another method is the pop method. By default, it removes the last item from a list. We write letters dot pop, then run. And we see James was removed from this new formed list. Pop is unique because it allows us to remove an item but still work with that item. Assign letters dot pop to a value like popped underscore letter. So now when I run, I'm going to pass in popped letter by adding another print statement, then run. And we see James was removed from the list, but also displayed at the end because we can still play with the list. For sorting an item, we write numbers dot sort. I'm going to also print numbers before and after the sort method. Now we run and we see the items are in ascending order. 1, 2, 5, 7, 8, 8. If we want the items in descending order, then we pass in reverse equal true. So now when I run, we see it starts from the back by 887521. We can reverse the list to show the last item first and the first item last by writing numbers dot reverse. This time when I run, we see it shows 8, which was the last item, and 5, which was the first item last. Now, when it comes to sorting alphabets, this is interesting because if I write letters dot sort, there it is. Watch what happens when we print. You see, if you notice, the lowercase letters A and B are at the end of the list. They are not sorted in alphabetical order. The sort method using ASCII alphabetical, the sort method uses an ASCII-betical order and not alphabetical order. ASCII-betical order means all uppercase letters comes before the lowercase letters. To sort in alphabetical order, we can pass in key equal to str dot lower, then run. When I remove these parentheses. There it is. Now we see the list is in alphabetical order. Thanks for watching, and I will see you in the next session. In this session, we're going to look at tuples. A tuple data type is similar to a list data type. However, there are two differences between a tuple and a list. First difference is the tuple data type requires parentheses, while a list requires square brackets. Second, a tuple is immutable and a list is mutable. Therefore, we cannot change, add, or remove values from the tuple data type. If you're interested in more content, feel free to read the transcript on GitHub or download the source code. Also like this video and subscribe to my channel. Plus follow me on Twitter, connect with me on LinkedIn and Facebook. In the IDE, let me show you the difference between a tuple and a list. Copy the list data numbers. And I'm going to paste them. And I'm going to paste one more time for the tuple data type and change numbers to nums. Next, change the brackets, square brackets to parentheses, opening and closing parentheses. That's it. We can print the type by writing print, TYPE, opening and closing parentheses, and then pass in numbers. I'm going to copy and paste and change numbers to nums. Now when I run, the console shows list and the tuple. When it comes to methods, the tuple data type only has two methods. I'm going to print nums dot, and we see count and index. However, the list data type has many methods that includes count and index. There are more methods for the list data type because they involve mutating, better known as changing a value. I'm going to print nums dot count. Count lets us know how many times a value shows up in the tuple. Pass in 8. Then run. As expected, the console returns 2 because there are 2 number 8s in the tuple. How about if I change 8 to a number like 9, then run? The console returns 0 because there are no number 9s in the tuple. How about number 5? We see 1 because there's only 1 5 in the tuple. The index method lets us know the position of a value, so change count to index, then pass in number 8. Since there are 2 number 8s, Python will only return the first 8 in position 1. Run, and we see 1 in the console. The tuple data type only has 2 methods because they are immutable, cannot be modified. If we try to modify a tuple, then Python would return a type error. For example, if I write nums, opening and closing parentheses, 0 equals 3, this is a command to try and change the first number, 5, to a 3. We already see a brown background. Hover it, and it says tuples don't support item assignment. I'm going to write for the list. It's no problem. If we assign a value to the first item for a list data type by writing numbers, opening and closing parentheses, square brackets, equals 3. Also print numbers. And I'm going to also print nums. I'm going to run, and the console shows type error. Tuple object does not support item assignment, but shows an updated list that includes 3 as the first number. That's because there's no problem with assigning a different value to a list data type. However, most engineers use a list data type because there are more use cases to change, add, or remove a value. However, the tuple data type maintains protection when we do not want a value or a set of values to change. For example, if we had a program that involved coordinates. Coordinates are a set of numbers that identifies a point on a line. We should not change a coordinate because it locates a point. I'll write coordinates as the name, and I'm going to make the values be 2, 3, also 3, 4, and 1, 5. 2 and 3 is one coordinate. 3, 4 and 1, 5 are the other coordinates. Print the second coordinate, which is 3, 4, by writing print coordinates. And I'm going to pass in 1, which is the second set of items. The index position always start at 0. Run, and the console returns 3, 4. This is a use case for a tuple. Thanks for watching, and I will see you in the next session. In this session, let's look at sets in Python. A set has values that are not in order and does not return duplicates. It looks similar to a list data type and a tuple data type. Recall from the previous sessions, a list is created using square brackets, while a tuple is created using parentheses. There are 3 ways to create a set. In the IDE, the first way is by using the set function. Women equals set. Then we add parentheses. Within the parentheses, we add square brackets. And the second way is using the set constructor. Men equals set, followed by parentheses. This time, we add more parentheses inside the parentheses. The values for women will be Janet, Jane, Jazz. And we're going to add Jane one more time. The values for men will be Joe, John, followed by James 2 times. So we have duplicate values for men and women. Print the women values and also print the men values. When I run, notice that the values are not in order how I added them to the set and does not contain duplicate values. Women does not contain duplicate value Jane, and men does not contain duplicate value James in the console. The console starts with Janet for women and James for men. If I keep running, the order will change each time. This time it shows Janet and Joe, Jane and Joe, Jazz and James. The third way of creating a set is by using a literal. Do you see how the console shows the values inside curly brackets? We create set literals using curly brackets. The brown background for women and men says function call can be replaced with set literal. Let's write numbers equal curly brackets. Within the curly brackets, write values 1, 2, 3, 4, 5, 6, 7, 8, 9, 2 times. Then write 10. So the duplicate values are 9 and 1. Now let's print the numbers. When I run, the console shows an error because I did not add the S for numbers. Now we see values 1 through 10 in the console without a duplicate number that was returned for numbers. Also, a set does not support indexing. If I write square brackets, then add 1 for the index number, then run, we see type error with a note that says set object is not subscriptable. In previous Python versions, this type of error had a note that said set object does not support indexing. The error shows up because we are not able to access an item since there is no sequence order. For the set data type, we can check for a value or collection of values using built-in functions. Let's start by creating some new set data types like even numbers, odd numbers, and prime numbers. For evens, they will equal curly brackets, 2, 4, 6, 8. Let's go ahead and add 0 also. And for odds, they will equal curly brackets, but start with 1, 3, 5, 7, and 9. Prime numbers, they will equal 2, 3, 5. I almost forgot the prime numbers. 2, 3, 5, 7, and 11. Now, a prime number is a whole number that only has 2 factors. The 2 factors are 1 and itself. Also, they can only be divided by 1 and itself. 1 is not a prime number because it only has 1 divisor. The first built-in function we are going to look at is union. A union combines 2 or more sets, then return a new set. Let's write evens dot union, then pass in odds. This statement will unite the even numbers and odd numbers. Print, then run, and the console shows numbers 0 through 9. If we do not want to add the word union, then we can write a vertical line symbol that represents union. Odds, vertical line symbol, evens. Print, then run. We see 0 through 9 for both statements. The intersection function is another built-in function. It helps to return a new set when 2 or more sets have a value in common. Let's look at the even numbers and the odd numbers. The even numbers are 0, 2, 4, 6, and 8. The odd numbers are 1, 3, 5, 7, and 9. Therefore, they do not have a value that's common. So if I write evens dot intersection, then pass in odds, print, we're going to see what the console returns. As expected, an empty set value. Now, as expected, it's empty because there are no common values, but the prime numbers have common values with even numbers and odd numbers. 2 is the only even number that's also a prime number. 3, 5, and 7 are the only odd numbers that are also prime numbers. To see even numbers that are prime numbers, let's write evens dot intersection, then pass in primes. Now, to see the odd numbers that are prime numbers, we can use an ampersand symbol, which represents the intersection function. Odds and primes. I'm going to print the sets for both, and we're going to see what the console returns. Run, and the console shows 2 for the even number and 3, 5, 7 for the odd numbers. There are more built-in functions that we can look at, but let's look at one more function. How about the difference function? It returns a new set after checking the difference between 2 or more sets. For example, the prime numbers are 2, 3, 5, 7, and 11. Now look at the odd numbers, 1, 3, 5, 7, and 9. 2 and 11 are numbers that are not in the odd number set. Therefore, the process will look at the prime numbers, then check to see which numbers are not in the odd number set. Let's write primes dot difference, then pass in odds. Print and run, and the console shows 2 and 11 as expected. Now, let's switch it around and look at the odd numbers 1, 3, 5, 7, and 9. What's the difference between odd and prime? 1 is not a prime number and 9 is not a prime number. Let's print the difference by writing odds minus prime. The minus symbol is a shortcut for writing difference. Print and run. The console shows 1 and 9 as expected. That's it for Python sets. Thanks for watching, and I will see you in the next session. In this session, we are going to look at a Python dictionary. The purpose of a Python dictionary is to store information in key value pairs. It's a special data type structure like a list, tuple, and set. We can access information from a dictionary using the key. In the IDE, the first step is to provide a name like tutorial equal curly brackets. The next step is to write our key value pair like name. Name is the key, and make sure to include a colon after the key. The value is Python programming. Always add a comma to separate the key value pairs. We can use almost any type of data for the value. Reserved words are not good values. This time, I will use double quotes for sessions as the key because it does not matter if we use single or double quotes. There will be 40 sessions. Let's use a Boolean value for the course is underscore valuable. True is the Boolean data type. Level is a good way for us to add a list data type. And the values for the list will be beginner, advanced. Dictionaries allow multiple items with the same key, but the last value will override the previous value. So if I write level again, then provide empty quotes, we see a brown background with a note that says dictionary contains duplicate keys, level. So far, I have used strings as the keys, but a key can be any kind of immutable data type like strings, integers, floats, or booleans. It can also be a tuple if the tuple contains only strings and the numbers. We cannot use a list because it is a mutable data type, meaning it can be modified. Most of the times, the key will be a string or integer. So let's use number 1 as the key and a duplicate value like true. True is the same value that's in is valuable key. At this point, we can print the tutorial, run, and the console returns all of the keys and values. Let's get one of these values by adding square brackets after tutorial, then specify the name key. Run. We see console. We see the console shows Python programming. If we wanted to see the number of sessions, then change name to sessions, then run. Now the console returns 40. Python returns a key error when using a key that is not available. For example, if I write is valuable for sessions, but remove the hyphen or remove the underscore, then run, the console returns key error is valuable. In our program, we do not want an exception, so a better way to access an item is to use the get method. The get method does not return a key error, but it returns none. So to get this, I will change the square brackets with .get. Within the get method, we pass in a key that is not valid. So this time when I run, we see none. The get method also allows us to provide a default value if we do not want to return none. To return a default value, after the key, I will write key not available. There it is. Run, and this time the console shows key not available. If we use a key that is available, such as writing the underscore and then run, we see true. We see true because the value is true. Although we added a default value, the console returns true because the key is valuable was found. I'm going to remove the default value and change is valuable to level, which is another valid key. Then run. The console shows beginner advanced as a list data type. To see the list data type, we can write type before tutorial, then run. And as expected, the console gave us list. Now, if we want to see another value like number 1, bool, let's change the level key to 1 and run. As expected, the console shows bool for Boolean. Python allows us to update an item, add an item, and remove an item from our dictionary. To update one value, we write the dictionary tutorial. Square brackets, add the key, which is 1, inside the square brackets. And the value is yes. This time when I run, the console shows str for string as the data type. I'm going to print the complete tutorial, and we're going to see the number 1 key is updated to show yes. Now, we can also update multiple items at the same time with one statement. And to do that, all we do is write the dictionary tutorial dot update, and within the parentheses, add curly brackets, then pass in the new dictionary values such as 1, yes. Add a comma, and I'm going to also include another dictionary such as trainer. And the trainer has a value of Rex. Now when I run, we see the new values. Number 1 for yes, trainer is Rex. Last but not least is removing an item from the dictionary. There's more than one way, but let's use the pop method. We write tutorial dot pop, then pass in a value like sessions. Also print tutorial before removing sessions. And I'm going to run, and the console shows how a value of 40 sessions was printed, then removed after Python programming. That's it for dictionaries in Python. Thanks for watching, and I will see you in the next session. In this session, we are going to open and write to a file in Python. There is a built-in open function to help us open a file. It returns a file object that contains methods and attributes. In the IDE, let's start by writing file equals open. At this point, we have two parameters. First is the file name ./file_test.txt. And the second parameter is the mode. Python offers 12 modes. However, we are going to look at 4 of those modes. W, write to a file. W+, write and read to a file. A, append. And A+, append and read a file. Append means add to the file. Let's start with the W mode, which writes to a file. It has one of two operations. If the file does not exist, then this command creates a new file. If the file exists, then this command overwrites the file. Run. You know what? Before I run, notice how file test is the name of the file, but the project does not have file test. So when I run, file test shows up, but when I open the file, it does not have any data. To add data, we write file.write. The write method allows us to write any string to the file. How about a header like name, tab, age, tab, gender, and insert a new line? It's always a good practice to close the file. File.close. The close method flushes information that prevents us from reading or writing to the file. Run, and this time we see the header information, and it shows name, age, and a gender. Change the mode from write to append. Append, A for append is different. I'm going to copy and paste. Then change the name to James. Age, 25. Gender, male. Also add some hyphens to separate the header information. Name will have 4 hyphens. Age, 3 hyphens. Gender, 6 hyphens. Now, the append mode also creates a new file and writes to the file if the file does not exist. However, since the file exists, then the file pointer is placed at the end of the file, then writes new information. Here's the problem. It will write the first line, name, age, and gender, 2 times before writing the next 2 lines. Run and open the file. We see the header, name, age, and gender 2 times because we appended the hyphens, James, 25, and male. You know how I said the write mode has 2 operations? The write and read mode also has 2 operations. Let's overwrite the file by typing W+ and run. As expected, we see 3 rows of data. Now, let's append a row by changing W+ to A. Then copy the last line and change James to Jane, 25 to 34, male to female. This time, make sure to comment the first 3 lines because we only want to add the last line for Jane. Run, and we see the last line 2 times because I clicked I clicked run 2 times because I wasn't sure if it updated or not. So you know what? Let me do that one more time, and I'm going to put W plus. I'm going to uncomment the lines, first 3 lines, and I'm going to start over. I'm going to write to the file, and we see 3 rows of data. Now I'm going to change W plus to A, and I'm going to comment the first 3 lines again and uncomment the last line. And I'm going to start by hitting run, and we see the last line for Jane was appended, the updated information. There is a way for Python to automatically close an instance of the file by using the keyword with. With guarantees the resource is cleaned up when running our program, when it finishes executing. Similar to the regular way, we can open the file, but I'm going to add some more information that's as file. File is the variable. Now I'm going to keep it as append. Let me make it append A plus because we haven't done that yet. And I'm going to write file dot write, and the string will be Janice. Tab age will be 24. Tab, then write female. And I'm going to make sure to comment the previous statements and run. Open the file, and we see the last line starts with Janice, age 24, and female. That's it for opening a file, then writing to a file in Python. Thanks for watching, and I will see you in the next session. In this session, we are going to open a Python file, then read the file. This process is very similar to writing information to a file. So let's start by typing file equal open. The file name will be file test from the previous session. We are going to look at 2 modes, reading and writing to a file, then only reading a file. I'm going to add a comment for each mode, R plus for reading and writing to a file, R for only reading a file. An engineer can make a mistake and think there is no difference between R plus and W plus. I said we will look at 2 modes, but let's make it 3 modes. From the last session, I demoed W plus, which is write and read. And we see the difference between R plus and W plus. The names are reversed, write and read, write, read and write. Let's start with R plus, which read and writes to a file. So the file pointer will be placed at the beginning of a file. Unlike W plus, the R plus mode will not create a new file if the file does not exist. Also, it will not overwrite an existing file. When I go back to the program, I would change the file name from file test to file tester. This project does not have a file called file tester. Make sure to close the file by typing file.close. Run, and there is still not a file called file tester. The console shows file not found error with an exit code of 1. Although the R plus mode, which read and write, is not able to read a file that's not in the directory. So I would have changed R plus to W plus, then run. Now we see the file, the new file. When I open it, there is no data in the file. Plus, we see an exit code of 0 in the console, which shows it was a success. Since there is no data in the file, let's write to the file test, which is the existing file, by removing ER and changing W plus back to R plus. Open this file one more time. And we see there are 5 rows of data, which includes a header. I will update the header by making it all capital letters, A for age, G for gender, and also N for name. You know what? I'm going to change gender to a different name. So when I go back to the file, I'm going to write file.write. The string will be capital N for name, then tab. Capital A for age, then tab. For gender, let's make it MRF, male or female, then insert a new line. Run, and now the console shows the file header has been updated to show all capital letters with MRF instead of gender. And notice the cursor is at the end of F. The command did not overwrite the file, but wrote a new line at the beginning of the file. Those are the 3 differences between W plus and R plus. W plus would have overwritten the file. Watch what happens when I change R plus to R. Now this command is set to only read the file. Run, and Python returns an exception that says file.write is an unsupported operation, not writable. We cannot write to a file if the mode is read only. The mode is read by default. Therefore, if I remove R, then change the write line to a new message, a new string like default read. Only so when we read the file and run it, we see the same exception with a different message. Unsupported operation not writable. And we see default read. Now, I'm going to comment this write line and show you a different error that shows up if we try to read a file that does not exist. Place an S at the end of the file name, then run. The console shows not found error. No such file or directory. To read the complete file, we can write file.read. Also print to the console and remove the S from the file name. Run, and the console shows each line with the same 5 rows of information. If we wanted to write another way to the console, we can print each line using a for loop. So let me comment that line and write for line in file, colon, print the line. This time when I run, we see the same information, but it has a new line after each row. So I'm going to comment this row of information and show you another concept that I showed in the previous session, so we can automatically close the file by writing with. The keyword with closes the file handler and simplify the message, simplify and how we manage the file streams. Open, file name is file test. The mode will be R for read. And make sure to write as file with the colon. Print read file.read. And this time when I run, we see the console shows the same name, age, male or female. Personally, it looks better than skipping a line after each row. There is one more concept that I want to show you with the with keyword. And this concept allows us to open more than one file at a time. So if I write with open, the file name is file test. The mode A+ for append and write as file. But this time add a comma and not a colon. And the next row will also be open. Again with the file name. File tester. Remember the file I created earlier in the session that did not have any data? Let's write to this file. W+, write and read to that file as the test file. Uh-oh. In the first file, I will append and write one row. File.write. The string, John, tab. Age will be 40. And the gender is male. Insert a new line. Now for the second file, let's write test file.write. And the verbiage will be just a write and read test. Run and look at both files when I finish. We see the updated information in the file. Thanks for watching, and I'll see you in the next session.